It happened quietly. No press release, no announcement, just a single frame, uploaded at 2:14 UTC on the 20th of October 2025, hidden among hundreds of calibration files on ESA's deep space server. Within hours, it spread like wildfire through the small but obsessive community of comet trackers. The image was labeled ATLAS Hera RAW Frame 921b, and at first glance, it looked ordinary. But a few people noticed something that shouldn't exist: the plume. A vast jet of luminous gas, 6,000 kilometers long, is bursting directly toward the Sunday. Every instinct in astronomy says, that's impossible. Tails and jets are always pushed away from the sun radiation pressure, solar wind, the constant outward breath of our star. That's rule number one. And yet, here it was, a cosmic contradiction, captured in exquisite clarity. Imagine a waterfall climbing upward, smoke sinking into fire, ashes raining toward the flame that birthed them. That's what this image showed. Matter moving in defiance of physics itself. At first, most assumed it was a simple misalignment, a corrupted pixel field, maybe a reflection off the spacecraft's optical baffle. But when analysts rotated the frame, corrected orientation, and aligned it with heliocentric coordinates, the direction still pointed sunward. The jet was real, and worse, it was consistent. Minutes later, a quiet panic rippled through Slack channels of observatories across Europe. A new round of independent confirmations began. Tenerife's 2-meter TD telescope, the Paranal Array in Chile, and Mauna Kea in Hawaii all saw the same thing: a dense, bright streamer moving toward the sun with a measurable emission spectrum. No software artifact could mimic that. No compression ghost, no sensor bleed. It was emitting real photons, real molecules of cyanide, carbon dioxide, and nickel gas. Some called it the reversed comet. Others whispered, the anti-solar jet. A few, half-jokingly, named it the cosmic intake valve. Quote many snai, to they want have caught him. Whatever it was, 3i, Atlas, had just rewritten the first rule of cometary behavior again. It's almost poetic, isn't it? A traveler from another star, ignoring the laws of ours. In the following hours, data scientists at ESA's Hera Mission Control pulled the raw frames apart, pixel by pixel, running Laplacian filters, median subtractions, and cross-frame differentials. Every test came back clean. The plume wasn't noise. It was a real, continuous emission, oriented 13 degrees toward the solar vector. The initial explanation was simple. Maybe it was a rotation. If the nucleus was spinning fast enough, one active vent could, by chance, align with the sun during exposure. But the probability of that alignment persisting across multiple frames over 6 consecutive orbits of Hera's camera was less than 1 inch 50,000. Something else was happening. And the more you stared at that image, the stranger it became. The coma around the nucleus wasn't round. It was teardrop-shaped, as if drawn inward by invisible gravity. Its polarization map showed a negative asymmetry light scattering backward instead of forward. Even the faint halo of ionized hydrogen bent toward the solar disk. It was like the entire object was inhaling sunlight. Observers compared it to a heartbeat, a steady pulse of material, contracting and releasing, but always breathing in instead of out. Somewhere, deep inside that cold interstellar core, there was a rhythm, and once you see the pattern, you can't unsee it. Every subsequent image, from October 20 to 21, showed the same heartbeat signature, the same reversed flow. Each jet is stronger than before. It was no longer an anomaly. It was a behavior. By midnight, the debate had split into two camps: those who believed the image and those who refused to. The skeptics pointed to solar reflections, ghosting, and even cosmic ray hits. They said the direction of the plume could be an illusion caused by a parallax offset between Hera's narrow-angle camera and its magnetometer reference grid. But then, the Mars Express orbiter picked it up faint, but clear, confirming the same geometry from an entirely different angle. That changed everything. Suddenly, everyone wanted the raw telemetry. Spectrographs, polarimetric scans, ion counts, anything that could explain how a comet was breathing in sunlight. ESA's internal log shows more than 50 independent teams downloaded the dataset in less than an hour. One of them, the Deep Space Forensics Group in Oslo, ran a differential radiance test across the plume axis. Their result was unsettling. The light intensity along the jet wasn't decreasing with distance, as physics predicts. It was increasing. Each pixel closer to the sun glowed brighter, as though energy were flowing inward, drawn by some invisible siphon. That discovery hit the forums like thunder, because if the data were correct, the plume wasn't a passive exhaust at all. It was feeding. Imagine a candle whose flame pulls wax upward, a storm where rain climbs back into the clouds. Every rule of thermodynamics trembled for a moment that night. Somewhere in Darmstadt, the Hera navigation team cross-checked their timing data. If the jet was accelerating plasma toward the sun, Hera's sensors should detect a subtle change in particle density. They did. At exactly 3:22 UTC, a spike in solar wind reversal appeared, a localized backflow of ions moving against the expected stream. Only a few dozen protons per cubic centimeter, but the signature matched the direction of 3I, Atlas, within 1/10 of a degree. It wasn't just light. Something physical was pushing back. By dawn in Europe, the first headlines began to leak, not from official channels, but from astronomers posting fragments of their findings on X and Mastodon. We're seeing energy flow the wrong way. Possible sunward emission confirmed by 3 observatories. No known mechanism fits this. The tone was half awe, half disbelief. Nobody wanted to be the first to say what everyone was thinking. Maybe 3I, Atlas, isn't just reacting to sunlight. Maybe it's interacting with it. For decades, we've treated comets as dirty snowballs, leftovers of cosmic construction. They sublimate, they spin, they shed. Predictable, familiar. But interstellar visitors don't play by solar system rules. Oumuamua came first. Long, flat, silent, its trajectory defying gravity. Borisov followed, bright, conventional, a relief. Then came Atlas, the one that shouldn't exist, the rule breaker. The mirror turned inward. Now, with this single image, all 3 suddenly fit a pattern, a sequence that feels almost deliberate. By the time the sun rose over Hawaii, the 3I Atlas tracking channel had more than 2,000 active messages. Astronomers who hadn't spoken in years were pinging each other, sharing frame differentials, overlaying hydrogen alpha maps. One researcher wrote, "We're watching the impossible happen live." The moment felt quiet yet monumental, like standing at the edge of a law of nature and seeing it hesitate. So they called an emergency session, a joint meeting between ESA, NASA, and JAXA to determine if the image could be an error. The decision would come within 48 hours. Until then, the data remained open, and anyone who stared at it long enough felt the same chill. Because when you look at 3I Atlas on that October night, you can't shake the feeling that it's not just moving toward the Sunday, it's listening to it, and whatever it's waiting for has already begun. It's one thing to see the impossible, it's another to prove it. Within hours of the first Hera frames, the world's observatories began a silent race, not for fame, but for verification. Because every scientific instinct said, jets don't point toward their stars. If this were true, it would mean something fundamental was missing in our understanding of solar mechanics. So the data had to survive the gauntlet. Noise checks, optical recalibration, spectral cross-correlation, every filter, every test, every skeptical eye. ESA's Data Integrity Division started the first sweep at 5 UTC, October 21. They reprocessed the entire batch of raw images through 3 independent pipelines, one in Darmstadt, one at the Canary Islands Observatory, and a third at a private research cluster in Kyoto. The goal was brutal: find a mistake. If even a single frame was off, if one calibration star was misaligned, the illusion could collapse. But it didn't. At the same time, NASA's Deep Space Network joined the analysis. The Goldstone antenna received the Hera uplink logs and transmitted them to the Goddard Spectral Lab. A team led by Dr. Maya Jensen, one of the youngest data forensics specialists at the agency, cross-referenced the photon timestamps against solar flux measurements from the Parker Solar Probe. If the sunward plume was an imaging glitch, its spectral peaks should scatter randomly across exposures. Instead, they formed a smooth curve, a distinct molecular signature consistent with cyanide fluorescence. In other words, the plume wasn't a shadow, it was glowing from within. Dr. Jensen later wrote in her private notes, "I kept expecting to find compression noise, a JPEG ghost, a dead pixel trail, anything. But the more I subtracted, the more it persisted. The light wasn't reflected, it was emitted." It's not 10 May. Meanwhile, independent observers on Earth had already started their own checks. The 2.2-meter Tidy telescope in the Canary Islands switched to narrowband filters for nickel, iron, and CO, 2 lines. Chile's Very Large Telescope targeted the same coordinates, adjusting for atmospheric scatter. Mauna Kea Observatory in Hawaii followed with infrared confirmation at dawn. 3 continents, 3 instruments, 1 direction, always toward the Sunday. The odds of coordinated sensor error across that many platforms were statistically microscopic, so the tone changed. The skepticism didn't vanish, but it evolved from denial to discomfort, from that can't be real to what if it is. Will snow is not fall the result, in pride, in what she was no in 9. By October 22, the phenomenon had earned its unofficial name, the sun plume. It sounds poetic, almost gentle, but to physicists, it was terrifying, because it meant something out there was defying the dominant outward force of the solar wind. To confirm, teams at Kyoto ran a full Laplacian deconvolution of Hera's imagery, isolating the intensity gradient along the plume's spine. They found consistent ratios, a brightness fall-off proportional not to distance from the nucleus, but to distance from the sun itself. That single inversion flipped every model upside down. It implied the energy source wasn't internal, as in a normal comet outgassing. It was external, like a mirror designed to reflect light. In Washington, a late-night teleconference connected ESA, NASA, and JAXA. The question was simple, almost absurd. Could radiation pressure ever act in reverse? Dr. Jensen opened the session by showing a time-lapse, the plume moving frame by frame, each exposure sharper than the last. Then she froze the feed. "You're looking at negative radiation acceleration," she said. "Photon momentum appears to be flowing backward." No one spoke for several seconds. A senior ESA engineer finally broke the silence. "That's not how photons work." Everyone laughed nervously, the kind of laugh that hides panic. Outside the institutions, the public had no idea what was unfolding. A handful of astronomy channels posted short updates. Possible anomalous jet behavior observed in interstellar object 3I Atlas. But the deeper data remained in encrypted archives, circulating only among the agencies. They needed consensus-first confirmation so strong it couldn't be dismissed. So they built redundancy. 10 separate teams analyzed the same datasets using different algorithms. If any one of them broke the pattern, the claim would fail. All 10 matched. By now, whispers had begun spreading through scientific Slack groups and Discord servers. What if it's electrostatic? Just a phase in the raid inside, and for they justified in the fold in time. What if there's a magnetic inversion? What if the tail isn't a tail at all, but a field line? None of it made perfect sense, but all of it sounded possible enough to keep them awake. At the European Southern Observatory, Dr. Elias Monroe ran a spectral map comparing the 3I ATLAS plume to known emission lines from solar coronal loops. The overlap was eerie, as if the jet were mimicking the sun's own plasma frequency, resonating like a mirror echo. When he overlaid the datasets, the interference pattern aligned to within 1 part in 2000. That's not noise, that's synchronization. He sent the graph to ESA headquarters with a single sentence. "It's following the sun's rhythm, even affairs to the rect of the specting." Confirmation wasn't a single moment, it was a slow surrender. Every test that should have disproved the anomaly only deepened it. Spectral purity, intact. Directional vectors, consistent. Chemical composition, coherent. No matter how they rotated the frame, recalibrated the sensors, or switched filters, the plume refused to vanish. And slowly, the tone of the reports changed. Where the first draft said, "artifact likely," the next said, "unexplained consistency." Then, possible real phenomenon. Then, finally, confirmed anomalous emission towards solar vector. Instantly and freshened, in the MEDID. When the official bulletin went out on October 23, it was only 2 sentences long. ESA Hera, imaging data confirm active emission from interstellar object. 3I Atlas directed toward the Sunday. Further analysis pending. That was it. No adjectives. No speculation. But inside the agencies, those 2 lines hit like a thunderclap, because buried between them was a silent admission. The laws they relied on had bent. Over the next 24 hours, observatories worldwide adjusted their schedules. Time slots originally assigned to exoplanet surveys were diverted toward one target, Atlas. Even the James Webb Space Telescope reoriented one of its mid-infrared spectrometers for a narrow window at 7 UTC, October 24. It captured only 14 minutes of usable data before the object slipped behind the solar glare. but it was enough. The plume is emitted in discrete pulses, 4 hours apart. Each pulse is stronger, cleaner, and slightly red-shifted. The rhythm was identical to the one Hera had detected earlier, the strange, mechanical heartbeat of an object that shouldn't be alive. Scientists love symmetry. They also fear it, because perfect rhythm implies intention, and intention implies design. But to admit that is to step beyond science, and none of them were ready. So the official papers used safer words: periodic modulation, self-regulating outgassing, unknown vent geometry. Privately, though, the conversation had shifted. The sun plume was no longer a curiosity. It was a question, one that stared back. Dr. Jensen described it best during a midnight interview months later. It felt like the object was aware of the Sunday. Not alive, but responsive, as if it recognized the pattern of energy it was receiving and returned it in kind like two instruments tuning to each other. That sentence would never make it into the official report, but it captures the moment perfectly. Because on the 24th of October 2025, humanity confirmed something unthinkable. A comet, born between the stars, was breathing toward the sun, and the sun, somehow, was breathing back. By October 25, the obsession had shifted from direction to composition, because if the plume truly defied solar radiation, its chemistry had to be just as strange. And it was. The first spectral packets from Hera's onboard analyzer came through at 9:12 UTC. They showed something no comet scientist wanted to see: a nickel-rich signature with almost no trace of iron. For a moment, the lab fell silent. Then, laughter, the nervous kind that means someone's sanity is in question. "That can't be right," one analyst said. "Iron always comes first. Always." But the data refused to blink. Wavelength peaks at 341, 356, and 379 nanometers matched metallic nickel fluorescence with an intensity ratio of 12:1 compared to iron. That shouldn't happen in nature. Not in interstellar dust, not in solar comets, not anywhere we've ever looked. They reran the analysis using every known reference spectrum. Still nickel. Still no iron. Dr. Lynn Aras, a materials astrophysicist in Oslo, summed it up bluntly. "It's like finding stainless steel in a snowball." This is not thank yous. Normally, cometary chemistry is predictable: a frozen soup of silicates, iron grains, and water ice, bound by carbon dioxide and ammonia. When sunlight hits, those compounds sublimate and stream outward. The mix of metals always mirrors their cosmic abundance. Iron dominates, nickel follows in trace amounts. But Atlas had inverted that order. It was as though the periodic table itself had turned upside down. By mid-morning, the nickel anomaly was confirmed by 3 observatories and cross-checked against archived Hera spectra from earlier flybys. Those older frames, once dismissed as overexposed, now revealed the same imbalance hiding in plain sight. The comet had always been nickel-heavy. Nobody had thought to look. What made it worse was the ratio's stability. In every exposure, regardless of angle or temperature, nickel intensity held steady, while iron dropped further and further into noise. No natural process could refine material so selectively. And then came the carbon dioxide data. The CO2 to H2O ratio measured 8:1, 8 times higher than the norm. It was like a comet made of dry ice and metal, not rock and frost. Even the trace gases were bizarre. Among the faint lines of the spectrum sat a thin, unmistakable spike at 334 nanometers. Hydrogen cyanide, HCN. The same compound is used in electroplating nickel on Earth. That single coincidence sent shockwaves through the community. Because to anyone who'd ever worked with alloys, that spectral fingerprint looked disturbingly familiar. By evening, forums were filled with wild theories. Some said Atlas had formed near a carbon-rich star, where iron condensed less efficiently. Others claimed it might be a fragment of a metallic asteroid, stripped of iron by radiation pressure during interstellar drift. But none of those models fit the ratios. Even the most extreme supernova yields couldn't produce that much nickel without some accompanying iron. So the explanations started bending toward the unthinkable. If it wasn't natural, then what was it? Inside ESA's Darmstadt lab, Dr. Ara set up a thought experiment. She simulated nickel carbonyl NiCoke, a volatile metal compound that glows under ultraviolet radiation. Under certain vacuum conditions, it could emit the same spectral peaks Hera was detecting. But there was a problem. Nickel carbonyl breaks apart at 50 degrees Celsius. Atlas's surface temperature, near perihelion, was over 300 degrees Celsius. The molecules shouldn't survive. And yet, somehow, they were not only surviving, they were thriving, pumping light as if being replenished from within. By 22 UTC, the working document on ESA's internal network carried a bold new title: Metal, Carbonyl Hypothesis, Preliminary. Potentially was be found. 18 user Forsner, allies there found. It suggested that the plume's chemistry wasn't random venting, but an active reaction zone, a self-sustaining layer, converting solar energy into molecular emission. One reviewer wrote in the margin, "This reads less like geology and more like engineering." No one disagreed, because if the nickel wasn't residual dust, if it was organized, patterned, maintained by reaction thresholds, then Atlas wasn't just shedding material, it was managing it. The next morning, Hera's magnetometer picked up subtle fluctuations near the object's surface, oscillations synchronized with the 4-hour pulse. Every emission of light coincided with a faint magnetic tremor, as though the material itself was responding to a timed current. ESA's control team compared the pattern to data from the old Rosetta mission at Comet 67P. The difference was staggering. Rosetta's readings were chaotic, a natural storm of ions and eddies. Atlas's field, by contrast, was regular, smooth, rhythmic, like a circuit switching on and off. When plotted against nickel emission intensity, the correlation coefficient was 0.986, almost perfect. It wasn't a coincidence anymore, it was choreography. Meanwhile, at NASA's Goddard lab, Dr. Jensen's team performed a density-weighted decomposition of the spectral lines. They expected a random scatter of heavy metal transitions. Instead, they found sharp harmonics, discrete energy levels consistent with controlled plasma confinement. One intern stared at the chart and whispered, "It looks like it's resonating with something." Someone else replied quietly, "Or someone." The joke didn't land. No one laughed this time. Then came the strangest discovery of all. The ratio of nickel to iron wasn't constant after all, it was changing. Slowly, in perfect sync with Atlas's approach to the Sunday. Every 4 hours, the nickel line brightened, while the trace iron dipped even further. When the data was extrapolated forward, the model predicted something astonishing. At the closest solar approach, iron would vanish entirely from the detectable spectrum. It was as if the object were refining itself in real time. No known chemistry can separate elements like that in the vacuum of space. No comet should evolve chemically as it orbits, yet the evidence was undeniable. Each observation reinforced the same eerie logic that Atlas was transforming, not disintegrating. On October 26, an emergency meeting was convened. ESA, NASA, and the Institute for Cosmic Chemistry all logged in. 30 researchers from 12 countries stared at the same spectra. Dr. Aras opened with a slide labeled Comparative Planetary Metallurgy. She showed 3 spectra, one from Atlas, one from a lab sample of superalloy Inconel, and one from pure nickel carbonyl gas. The peaks lined up like fingerprints. You could hear the collective intake of breath through the microphones. "It's not proof," she said softly, "but it's a pattern," someone muttered. "Or a design." Of course, the official minutes would never say that. They use safer phrasing. The composition suggests high-temperature processing, inconsistent with primordial formation. But between the lines, everyone understood what it meant. If those nickel-based compounds were ever forged intentionally, even once it would change how we define natural. By nightfall, Hera transmitted one final spectrographic scan before its instruments entered safe mode. The signal was faint, distorted by solar interference, but within the static lay a narrow resonance peak, a frequency only metallic lattices produce. It flickered at exact multiples of 440 Hz. The same frequency that human engineers use to test structural vibration in spacecraft. Coincidence? Maybe. But to the exhausted scientist watching the graphs pulse on their monitors, it felt like something else. Something whispering through numbers. Something built. Later, in her private notebook, Dr. Jensen wrote a single line. "Nickel without iron. Logic without nature. Maybe the universe is showing us a mirror." No one quoted that in the papers. But everyone remembered it. Because after the 26th of October 2025, the story of 3I, Atlas, was no longer about motion, or light, or geometry. It was about composition, about the possibility that somewhere, in the cold between stars, an object had learned to hold its shape against the laws of physics, and we had just found it. It began as a whisper in the data, a faint tremor buried inside the electromagnetic logs. At first, nobody noticed it. But when Hera's magnetometer resumed its stream on October 27, analysts saw something repeating beneath the static. A low-frequency oscillation, perfectly timed, every 4 hours, almost to the minute. The discovery came from a young technician named Alex Moreno, reviewing telemetry at 3 a.m. in Darmstadt. He thought it was an equipment glitch, a heartbeat caused by the satellite's gyros. But when he cross-checked against Hera's redundant backup systems, the pattern was identical. And when he compared it with emission spikes from Atlas's nickel spectra, the timestamps matched exactly. At 1:06 UTC, Hera recorded a pulse of light. At 5:06 another, then 9:06, 13:06, like clockwork. Each event lasted roughly 12 minutes, climbing sharply in brightness before fading into the void. Moreno called his supervisor. Within an hour, half the mission control room was staring at the same repeating graph, a waveform that looked unsettlingly biological. "It's breathing again," someone whispered. By morning, the anomaly had a name: the 4-hour pulse. What made it haunting wasn't the timing itself, but the precision. Natural processes are messy, random, irregular, subject to chaos. But this was perfect. If it were a rotation, the period would drift as the nucleus vented gas and lost mass. If it were precession, the angle would wobble with every orbit. Yet the pulse remained steady, measured to within 0.002% variance across 3 cycles. The signal was traced to a repeating burst of nickel emission, coupled with a synchronous magnetic flutter, the same rhythm Hera had detected in Part 3's data. Light and magnetism, dancing together in locked step. No one had ever seen that from a comet, not even remotely. Dr. Lynn Aris was the first to say it aloud. "Whatever's inside Atlas, it's regulating itself." The phrase hung in the air like a forbidden thought, because regulation implies feedback, and feedback implies design. But Aris wasn't claiming intelligence, not yet. She simply pointed to the numbers. The periodic release of material wasn't chaotic venting. It was modulated each outburst following a harmonic ratio of 1, 2, 4, when compared to its preceding amplitude. That sequence was eerily similar to how engineered oscillators stabilize resonance. To test the idea, teams at ESA and NASA built simulated models using magneto-hydrodynamic equations. They tried every natural mechanism they could think of: rotational jet alignment, diurnal heating, cryovolcanic feedback. None produced the clean, periodic signal Hera was recording. Only one configuration came close: a model in which internal cavities acted as pressure chambers, releasing vapor through narrow vents once a critical threshold was reached. Like a valve, like lungs. "So, you're telling me the comet breathes?" someone asked during the review call. "No," Aras replied. "I'm saying it chooses when to exhale." On October 28, the sun plume intensified again. The pulse grew brighter, longer, and for the first time emitted in 2 wavelengths simultaneously. One in cyanide, one in nickel gas. They pulsed together, offset by exactly half a phase. In signal processing, that's called a counterwave, the kind used in noise cancellation or harmonic tuning. Somehow, 3i, Atlas, was running 2 reactions at once, each mirroring the other, one outward, one inward, together, forming a steady, silent equilibrium. To the physicists watching, it looked less like a chemical reaction and more like a control loop, the hallmark of an engineered system. At Kyoto, a deep learning model trained on Hera's telemetry was run through the dataset. The AI wasn't told what to look for. It found correlations no human had considered. Minute phase shifts between magnetic flux and luminosity peaks. When plotted in 3 dimensions, the curve traced a perfect sine spiral. 4 lobes, 4 hours apart, forming a continuous cycle. The AI labeled it automatically. Stable periodic emission type omega. Nobody knew what type omega meant. It was just a placeholder in the code. But the name stuck. Later that day, Dr. Jensen ran an overlay between Hera's 4-hour data and the sun's own solar wind patterns. To her shock, the peaks aligned. Every pulse from Atlas coincided with a slight dip in the sun's local magnetic flux, as if the object were syncing itself to the star's heartbeat. "It's not just pulsing," Jensen said. "It's keeping time." Her words spread through the chat logs, like electricity. The realization was dizzying. A fragment of interstellar debris, cold, ancient, silent, had somehow tuned itself to the rhythm of the Sunday. By evening, scientists began to call it the metronome effect, because every 4 hours, somewhere between Mars and the Sun, a comet was keeping perfect cosmic time, a ticking heartbeat echoing through plasma and light. It didn't drift. It didn't fade. It simply was. And as the hours turned to days, that steady pulse started to feel less like data and more like a countdown. The more they measured it, the clearer the rhythm became. Every 4 hours, the brightness curve rose, peaked, and fell like breathing on a cosmic scale. Each cycle slightly stronger than the last, each pulse carrying just a fraction more energy. It wasn't random. It was building. By October 29, the Hera console room had the pulse graph pinned to its main display. You could almost feel it, a silent tempo syncing the room itself. Technicians joked about scheduling coffee breaks between beats. But under the humor was unease, because something about that regularity didn't feel passive anymore. It felt anticipatory. At 9:06 UTC, the fifth pulse hit. The emission flared across all visible bands, spilling into ultraviolet. Hera's spectrometer was briefly saturated, forcing a reboot. When data resumed, engineers noticed something new. The pulse had produced a ripple, a shockwave of charged particles propagating back along the solar wind, a reverse current, as if the comet had briefly exhaled energy, then inhaled the sun's response. The telemetry trace looked eerily like a heartbeat monitor. A sharp spike, a pause, then a mirrored return. Light, pause, echo. Light, pause, echo. Over and over again. "It's listening," Jensen whispered. "It's waiting for the sun to answer." No one replied. There was nothing to say. Outside the agency networks, the public still didn't know. The official bulletins spoke only of enhanced periodic outgassing and magneto-hydrodynamic interactions. Times and for the wrecker, dry words hiding what felt, to the people watching it live, like the first whisper of a dialogue between star and stone. At 13:06 UTC, the sixth pulse arrived brighter, cleaner, and this time visible even from ground-based telescopes. Observers in Chile recorded a faint flicker of polarized light, trailing 4 minutes behind the main emission. When they plotted it, the flicker formed a descending sequence: 4, 2, 1, 0.5. The ratio was exact, a mathematical symmetry so precise it sent shivers through everyone who saw it. ESA called an emergency joint review with NASA and the Solar Physics Consortium. The meeting lasted 7 hours. They examined every model tidal stresses, rotational harmonics, thermal cracking. None matched the timing, none explained the feedback delay. Finally, Dr. Lynn Aras broke the silence. "What if the pulse isn't a side effect?" she said. "What if it's the mechanism?" The room went still. She pulled up the simulation. Her team had been refining a 3D render of Atlas's nucleus interior. It showed cavities layered like a honeycomb, connected by narrow conduits. Each vent opened sequentially, releasing pressure, then closing again, not chaotically, but with orchestration. When the model ran, it produced the same 4-hour cycle. But the strange part wasn't the timing, it was the waveform. The simulated pulse matched Hera's data down to microseconds. The only way for that to happen was if the comet's internal chambers were somehow communicating. Gas flows shouldn't coordinate. They shouldn't wait their turn. But this one did. Later that night, as the mission logged its 7th pulse, the team noticed the light curve had developed sidebands, small oscillations riding on top of the main wave. To an engineer, they looked exactly like modulation, as if the signal now carried information. Nobody dared say it out loud, but someone typed 3 words into the private Slack channel anyway. "It's transmitting something." The message stayed unread for minutes, blinking silently. Then, finally, Dr. Jensen replied with a single dot, a placeholder, an acknowledgement. Meanwhile, the sun responded. Solar wind sensors on the Parker probe registered minute oscillations matching Atlas's timing, tiny ripples in the stream of plasma, 4 hours apart. They were small enough to ignore, but they were there. The sun, too, was pulsing back. "Feedback loop confirmed," Jensen wrote in her report. "Causality uncertain." The phrase would become infamous later, the perfect scientific euphemism for "we don't understand what's happening." In the following days, the rhythm continued. Perfect, endless. Every 4 hours, the system exhaled light and magnetic flux, and every time, the universe seemed to hold its breath before answering. Across the globe, telescopes tuned in. Every instrument that could point toward the inner solar system did. Even the amateur astronomers began to notice the clockwork pattern in the photometry data. On forums, someone wrote, "It feels like a signal, Not to us, but to the Sunday. Another replied, maybe they're talking, and we just happen to be in between. No one laughed anymore. By October 30, Hera's onboard instruments began to overheat under constant exposure. The mission team reduced sampling frequency to avoid burnout. But even at half resolution, the heartbeat was unmistakable, steady, patient, and utterly foreign. Every scientist watching it sensed the same quiet dread, that the pulse wasn't just a rhythm. It was a threshold. Something was counting down not to an explosion, but to an event. That night, as the 8th pulse rolled in, the sun plume flared to its brightest yet, a blinding column of nickel-blue light piercing the darkness between worlds. The data froze for 7 seconds under radiation overload. When the feed returned, Hera's cameras caught a brief shimmer at the base of the plume, a flicker shaped almost like a spiral. Then it vanished. Moreno stared at the image in silence. He zoomed in frame by frame. Pixels blurred into abstraction, then resolved again. It wasn't a trick of focus. The structure was real. A twisting, coiling pattern buried in the heart of the jet, rotating once every 4 hours. A signature, a symbol, a clock. And as the 9th pulse prepared to ignite, everyone at Mission Control found themselves doing the same impossible thing, counting on it. One beat, then another, until the rhythm of an object from another star was no longer something they were studying. It was something they were feeling. By sunrise on the 31st of October 2025, the world had no idea that somewhere in the quiet dark between Mars and the Sun, time itself had started to accelerate. Not metaphorically, literally. The 4-hour pulse of 3I, Atlas, was tightening. Every cycle arrived seconds earlier than the last, as if the object were winding its own clock, pulling each beat closer to the next. Inside ESA's mission control in Darmstadt, no one joked anymore. The soft murmur of technicians, the low hum of cooling fans, the rhythmic blink of monitors, it all blended into a single pulse that matched the comet's. Every light in the room seemed to flicker in sync with the telemetry stream. They didn't notice at first. Then someone did. "It's pacing us," a voice said quietly. Nobody laughed. For days, Hera had been chasing data, orbit after orbit, pulling in terabytes of readings from a dying star and a foreign traveler. Now, those readings told one clear truth. There would be no second window. Once Atlas swung behind the Sun on November 3, the connection would vanish for months, maybe forever, if the object disintegrated in the glare. The team had exactly 72 hours left. 3 days to learn why the laws of physics had bent. 3 days to watch a heartbeat no machine had made. 3 days before the universe turned the page. At 9:06 UTC, the 15th pulse arrived. The room dimmed as every monitor flared, brightness rising in a smooth mathematical curve, peaking for 9 minutes, then fading again. Hera's sensors recorded a surge of nickel emissions so intense that its onboard algorithms classified it as quasi-coherent plasma output. That phrase meant nothing to the journalists who would later read it, but to the engineers watching live, it meant one terrifying thing. It wasn't venting anymore. It was modulating. The pattern was no longer natural. It had shape, structure, intent. At 10:22, Dr. Lynn Aris called a global coordination session. ESA, NASA, JAXA, ISRO, and the Solar Physics Consortium. 35 scientists from 5 continents linked across a trembling line of audio delay, each hearing the faint background beat of Hera's pulse through the static. Aras opened her screen share with a single sentence. "We're out of time." She zoomed in on the data cascade, the sun plume's nickel intensity doubling every 8 hours, cyanide emission amplifying in lockstep. The power curve wasn't exponential. It was step-to-ladder, climbing toward a ceiling no one could see. "It's counting something," she said. "We just don't know what." The official hypothesis was cautious. Runaway sublimation, driven by internal cavities heating unevenly. But the private chat threads told a different story. Words like synchronization and harmonic convergence started appearing. Someone from NASA wrote, "It's not sublimation, it's signaling." No one dared agree, but no one deleted the message either. The mission schedule became relentless. Every 4 hours, Hera's sensors spiked, and every 4 hours, a new storm of plasma erupted across the sun plume, visible now, even through ground-based telescopes at twilight. The object's glow had grown so intense that amateur astronomers in Chile began filming it. A soft, breathing pulse just above the horizon. When the footage hit social media, it went viral within hours. "Comet that breathes toward the sun," read one headline. 4-hour heartbeat detected in space, said another. The world thought it was beautiful. No one realized it was a countdown. By 13:06 UTC, Hera's cameras began to overload. The pulse frequency was still rising, the energy wave sharpening into clean sine curves. Data scientists compared the pattern to human-engineered oscillators, the kind used in stabilized circuits or nuclear fusion chambers. The resemblance was unnerving. At 15, Dr. Jensen posted a short note to the internal network. The periodicity has crossed the 99.998% stability threshold. It's more consistent than our own onboard clock. Constekting died. The comment sparked silence in the chat, because if Hera's atomic clocks could drift and Atlas's couldn't, then somewhere out there, a natural object was keeping better time than humanity. That evening, the atmosphere inside Mission Control grew heavy. The wall clocks all ticked at once, echoing softly through the room. Someone muted them. "The object is not decaying," Aras said. "It's cohering." She didn't explain what that meant, and she didn't have to. They could all feel it. That sense of acceleration without motion, that eerie calm before data, turns into revelation. It was the stillness of a breath held too long. At 20 UTC, Hera began its final high-resolution observation run. Engineers rerouted all power from navigation to instruments. Even the temperature control systems were dimmed to conserve energy. "Every byte counts," Aras said. Then, quieter. "Every second counts." Outside, the comet continued its silent rhythm. 4 hours. Then 4 hours again. The universe had become a metronome, and the human race was finally aware of its own smallness. Listening to a beat older than fire, steadier than breath, and utterly alien. By the morning of the 1st of November 2025, Hera was already dying. Its power reserves had fallen below 30%. The spacecraft was never designed to stare this close into the sun, and yet it kept its gaze locked on the blue-white plume, as if drawn by instinct or by duty. The 4-hour cycle had tightened again. The pulse now came every 3 hours and 57 minutes. A shift small enough to ignore, but large enough to unsettle. At 6:03 UTC, the next surge hit. Every detector on Hera lit up like a city seen from orbit. Spectrometers saturating, magnetometers trembling. Radiation monitors are spiking off scale. The sun plume doubled in brightness. The plasma bridge that had once looked like a thread now stretched into a visible arc, connecting the comet and the star, a translucent vein of light pulsing with electric breath. "It's feeding again," Dr. Jensen whispered. "Only this time, it's not stopping." Across the globe, solar observatories confirmed the impossible. The sun itself had begun to flicker. Not chaotically, rhythmically. Each pulse from Atlas now echoed across the solar surface, sending tiny ripples through the corona, as though the star were answering a question asked by something small and far away. It was no longer a coincidence. It was resonance. The idea spread through Mission Control like static. 2 celestial bodies, one the furnace of life, the other, a fragment of dead interstellar stone, beating together in perfect time. No one could explain it, and maybe no one wanted to. At 9:57, the 17th pulse arrived, the strongest yet. Hera's camera feed flooded with light, a blooming flare that overexposed every sensor for 7 whole seconds. When the picture returned, the sun plume had split. 2 jets now arced from Atlas, one aimed directly toward the sun, the other way, tracing a perfect symmetry across the void. Each jet pulsed in alternating rhythm, one inhaling, one exhaling. The heartbeat had become a breath. "Bidirectional plasma," Aras said flatly. "Intake and release. Closed system." Her voice trembled on the last words, because what she described wasn't a comet anymore. It was a reactor. At 11 UTC, Hera's last diagnostics came in. Magnetometer phase drift, 0. Spectral interference, none. Signal delay, perfectly in sync with solar wind oscillation. Even as systems failed, the object's pulse stayed pure, unshaken by radiation, gravity, or chaos. Someone whispered, "It's stabilizing," but the word sounded wrong, because stability implied balance, and this felt more like preparation. The countdown clock on the wall ticked quietly toward the next pulse. 3 hours, then 2, then 1. When the moment came, 14:54 UTC, Mission Control went silent. Every screen dimmed, except one, displaying Hera's live feed in grainy monochrome. The sun plume began to narrow, its edges are drawing inward like a closing iris. The light thickened, turning from blue to white, from white to something colorless. A blinding absence. Then, for exactly 12 seconds, Hera recorded a structured pattern embedded in the light. 3 frequencies, 7 harmonics. Repeating, it wasn't a random oscillation. It was encoded. "That's data," Jensen said, voice barely audible. "That's a signal." The words hung in the room like smoke. At 14 hours 55 minutes and 12 seconds UTC, Hera's transmission buffer overflowed. The final packet came through, corrupted, but one frame survived. A single still image. A spiral of light, shaped like the double helix of DNA, rotating at a rate of 4 hours per cycle. A perfect echo of the rhythm they'd been following for weeks. Then the feed went black. For a long time, no one in the control room moved. Some stared at their screens, some at the clocks, a few at their own trembling hands. It felt wrong to speak, like talking in a cathedral. Finally, Dr. Aras whispered, "We've reached the end of the window." No one answered, because they all knew what she meant. Hera would burn in less than a day, swallowed by the solar winds it had tried to chase. But before it died, it had watched a miracle. A pulse that turned into a signal, a comet that turned into a conversation. At 15 UTC, the world outside still spun unaware. People scrolled their phones, children played, traffic lights blinked red to green to red again. And in a silent room in Darmstadt, 30 scientists sat motionless, listening to the tick of a clock on the wall, the only sound left, marking the end of the longest 4 hours in human history. No one knew if the next pulse would come. No one knew what it meant. But deep down, every person in that room shared the same thought. If the universe ever wanted to speak, this was how it would begin. When the transmission from Hera ended, the silence lasted 3 days. 3 days of nothing but static, half-decoded telemetry and unanswered messages bouncing through the deep space network. No one wanted to admit it, but everyone knew Hera was gone. And yet, what it had left behind was enough to break a century of astrophysics. On the 4th of November 2025, the European Science Council issued a quiet directive: compile all verified data into a single forensic dossier. It sounded routine, but inside the encrypted archive labeled Atlas, Post-Contact, CLASS, Class 7, a new document began to form. A 212-page report listing every inconsistency, every violation of known physics, every unanswered question, 15 major anomalies, 15 reasons to reconsider everything we thought we knew about the universe. Anomaly 1. The direction paradox. All jets, tails and ion flows pointed toward the sun, a complete inversion of radiation pressure dynamics. Simulations confirmed that no known combination of gravity, spin, or thermal venting could reproduce the geometry. Every vector aligned sunward within 2 degrees. A violation so simple, yet so absolute, it defied correction. Anomaly 2. The stable pulse. Periodic emission every 3 hours and 57 minutes. No measurable drift across 48 cycles. Not rotational, not tidal. A perfect oscillator in a vacuum. Each pulse is consistent within microseconds, frequency matched to solar flux oscillations. Natural bodies don't keep time, machines do. Anomaly 3. Nickel without iron. Spectral lines dominated by metallic nickel with an Fe, Ni ratio of 1:12. Impossible under stellar condensation or impact ejection models. Trace HCN matched electroplating byproducts on Earth. If random, it's the most coordinated accident in chemistry. Anomaly 4. Carbon dioxide. Supremacy. CO2 to H2O ratio of 8:1. Cometry norm is 1:4. The plume composition resembled dry ice reactors more than frozen rock. Each pulse released more CO2 than expected from the total surface area, implying internal regeneration. Anomaly 5. The magnetic mirror. Hera's instruments recorded reversed ion flow solar wind particles accelerating toward the object. Localized field reversal extended thousands of kilometers. No natural comet can sustain inverse magnetism against a solar stream. This was a magnetic mirror, a structure engineered to reflect plasma inward. Anomaly 6. Bidirectional jets. Final frames revealed dual plumes. One sunward, one anti-sunward. Alternating in rhythm with the 4-hour pulse. Symmetry ratio 1, plus or minus 0.01. Natural outgassing never achieves parity that precise. Whatever controlled it did so with intent. Anomaly 7. harmonic coupling with solar activity. Every major flare in Atlas's data corresponded with a microdip in the sun's corona intensity. Lag time, 2.3 seconds. The star and the object behaved like two oscillators linked by resonance. If coincidence, it's statistically invisible. By the time the seventh anomaly was confirmed, skepticism had turned to fear. The tone of the reports changed, no longer cold and clinical, but hesitant, uncertain, even apologetic. ESA's internal memo read, "We can explain each anomaly individually, but not simultaneously. Their combined probability is less than 10 to the power of negative 23. The dataset is internally consistent, yet globally impossible." He was now end of 9. Anomaly 8. Variable chemical state. Spectral composition shifted with heliocentric distance. Nickel emission grew as the object neared the sun, while trace iron faded entirely. Instead of sublimation loss, the process appeared reactive, as if energy input converted one element into another. Some analysts called it solar alchemy. They weren't far off. Anomaly 9. Polarization reversal. Light scattered backward, not forward. A negative polarization of 4.2% recorded consistently across visible and near UV bands. Such optical behavior requires layered dielectric materials, thin films tuned to specific wavelengths. It was less like dust, more like a coating. Anomaly 10. Perfect thermal retention. Surface temperature remained constant despite changing solar flux. At perihelion, where a normal comet would spike above 300 degrees Celsius, Atlas stayed near 126 degrees Celsius. Somehow, it absorbed heat without heating up. Thermodynamically impossible unless the absorbed energy was being stored. Anomaly 11. Energy storage signature. Hera's final magnetometer data showed trapped plasma loops orbiting the nucleus, decaying at discrete intervals. Energy wasn't radiating randomly. It was being released in controlled bursts. Each pulse emitted the same amount, 2.8 times 10 to the power of 10 joules. The precision suggested a regulation mechanism, an energy buffer. By this point, scientists stopped pretending this was a coincidence. They started calling it what it looked like, a system. But systems require architecture, and that meant structure. So analysts began re-examining Hera's imagery, the faint spiral seen before the blackout. At extreme contrast, the outline of the nucleus revealed faint geometric ridges, repeating every 33 degrees longitude. No one said the word design. They didn't need to. Anomaly 12. The geometric nucleus. Surface topography displayed symmetrical ridges, possibly fracture lines or patterned plates. Spacing is uniform within 2%. Patterns persisted across thermal bands, ruling out lighting artifacts. It looked less like erosion, more like assembly. Anomaly 13. Constant mass distribution. Despite active venting, Atlas's rotational inertia remained unchanged. No measurable spin-up, no torque variation. That would require an internal compensator, something that maintains balance automatically. Anomaly 14. The communication frame. During the final pulse, Hera detected harmonic sidebands within the emission frequency. They repeated every 437.5 milliseconds. Mathematically consistent with binary encoding, though the meaning remains unknown. The term communication frame appeared once in internal notes, then was redacted. Anomaly 15. The residual field. After Hera's destruction, ground-based instruments continued detecting a low-frequency radio hum at 0.11 Hz. It persisted for 40 hours after contact loss, then faded abruptly. No solar phenomenon matches that pattern. It was as if the conversation had ended. When the 15th anomaly was logged, the report closed with 6 words. 15 anomalies and counting unresolved. But unofficially, many suspected there was a 16th. Something Hera had seen in its final frame, the spiral pattern embedded in the light. No one could prove it existed, yet every scientist who studied the data described the same image afterward. A spiral of light coiling inward, as though the universe were looking back. The dossier was finished by midnight, but nobody left the building. The team sat beneath the humming lights, staring at the last page 15 numbered paragraphs that shouldn't exist. Outside, rain drifted against the glass. Inside, the hum of servers filled the air like static grief. Officially, the file was closed. Unofficially, it was only beginning. The morning brief at ESA headquarters was unlike any other. No graphs, no equations, just silence. Each department head read the same lines over and over, as if repetition could make them less absurd. Someone finally said what they all felt. "We can't publish this. It reads like religion." But facts don't ask permission to exist, and so the data remained cold, mathematical, irrefutable. 15 anomalies, sealed inside a classified archive that no one dared delete. By noon, fragments had already leaked. A redacted summary appeared on an encrypted astrophysics forum, posted under a pseudonym, Helios, residual. Within hours, it spread through private servers, then to journalists, then to the public. The world read about a comet that inhaled sunlight and a heartbeat in the void. Wantelextrom. Most dismissed it as fiction, but a few didn't. Across the Atlantic, at NASA's Goddard lab, Dr. Jensen sat alone, watching Hera's final uncompressed telemetry frame the one no one else had seen yet. Hidden in the static, she found something peculiar. A cluster of data bits that didn't belong. When decoded, they formed a checksum pattern 16 blocks long. It wasn't telemetry noise. It was deliberate. She ran the block sequence through Fourier analysis. Each segment pulsed at frequencies corresponding to the 15 anomalies in the report. But there was one more, a 16th, buried between them. A gap of silence exactly 4.37 seconds wide. "The missing one," she whispered. "The anomaly we didn't list." She named it quietly in her notes. Anomaly 16, the silence interval. Later that evening, she shared the finding with Aras. The response came 5 minutes later, a single sentence. "Don't add it to the report." Jensen didn't, but she couldn't stop thinking about it, because silence is data too. Over the next weeks, analysis continued in secret. Spectral models, plasma simulations, resonance mappings, every test reached the same impossible conclusion. The 15 anomalies weren't separate flaws. They were interlocked behaviors, a network of effects woven together, each feeding the next. The pulse created the plume. The plume bent the magnetism. The magnetism stabilized the jets. The jets sustained the pulse. A closed loop of function. A feedback machine. Something was maintaining equilibrium inside. Atlas, not chaos, but order. And order implies purpose. By mid-November, the word artificial began to appear quietly in the private memos, sometimes replaced by softer euphemisms. Engineered, regulated, non-chaotic system. But they all meant the same thing. The conversation had crossed a line that science wasn't ready to admit existed. During a closed session, an astrophysicist from Kyoto said what no one else would. "If it is natural, it's a kind of nature we've never met. If it isn't, we may have just recorded the oldest functioning artifact in the galaxy." The room went silent. No one contradicted him. Meanwhile, the residual radio hum persisted. Sensitive arrays in Chile and Australia detected faint periodic traces near 0. 11 Hz is the same frequency Hera had logged in its final hours. The signal decayed gradually, as though the source were drifting deeper behind the Sunday. Then, at exactly 40 hours post-contact, it vanished. Not faded, stopped. A cutoff so abrupt it felt intentional. That was the last heartbeat. After that, the sky went quiet. In December, a summary was prepared for public release, stripped of implications, edited down to harmless curiosity. The final paragraph read, "Further study required, no evidence of artificial origin." But the unedited draft, buried on ESA's internal drive, contained one extra sentence before deletion. 15 anomalies recorded, 16 suspected. The 16th is silence. Years from now, historians would call it the moment the scientific world blinked. Not because it didn't believe, but because it did too much, too fast. It's easier to doubt than to confront meaning. Easier to treat wonder as error than to admit that something might be listening back. When Dr. Jensen left the lab that night, she paused beneath the autumn sky. The stars were pale through the haze, the sun already far below the horizon. Somewhere out there, hidden behind its glare, Atlas was still moving. Silent, unseen, carrying the memory of 15 impossible patterns and one perfect pause. She closed her eyes. For a moment, she thought she felt it again. A faint rhythm, deep in the stillness, as if the universe were breathing just once more. She didn't look up. She just whispered to the dark, "We heard you." It started with one sentence, written in the margin of the anomaly report by an anonymous reviewer. If the structure behaves like a system, perhaps it was built as one. No one signed the comment, but everyone knew who wrote it. Dr. Lynn Aras, the same voice that had first said it chooses when to exhale. For weeks, her words were treated as scientific blasphemy. A whisper moving through hallways, across encrypted chat rooms, always prefaced by the same nervous phrase, off the record, but ideas have gravity, and this one, once spoken, refused to fall away. On the 10th of November 2025, ESA reconvened under the codename Project Helix. The agenda was deliberately vague: material characterization and unknown energy retention models. No one used the word engineered, but it hung in the air like static. Dr. Aras opened the meeting with a single image, Hera's last confirmed spectrum before the blackout. She zoomed into the metallic emission lines. Nickel at 341, 356, 379 nanometers, pure and sharp, almost too perfect. These aren't random reflections, she said. They're structured, layered, controlled. She pointed at the curve. The intensity rose and fell with mathematical precision. 12 harmonics nested in a repeating pattern. Nothing in nature produces coherence like this, she added. Nothing alive or dead. Silence. Then someone from NASA spoke. Unless it was meant to. That was how the engineered alloy hypothesis was born, quietly, reluctantly, like a secret no one wanted but couldn't ignore. The logic was brutally simple. If a comet displays chemical refinement impossible under stellar or interstellar conditions, if its emission ratios mimic known industrial alloys, if its structure maintains thermal and magnetic equilibrium through closed feedback, then, maybe, just maybe, it isn't a comet. Maybe it's a fragment of something built. The group began comparing Hera's data to known terrestrial materials. They overlaid the spectral lines of nickel, chromium, cobalt, and titanium superalloys. Inconel, Hastelloy, mnemonic, the metals humanity uses to build engines that must survive heat, radiation, and vacuum. The overlap was uncanny. 9 of Hera's peaks matched nickel-based alloys used in fusion chambers and spacecraft hulls. 3 more matched byproducts of electroplating under cyanide catalysis, the exact reaction hinted at by Atlas's hydrogen cyanide signature. It's as if someone built this from our own periodic table, said one analyst. Another replied, or maybe we've just been imitating them. The words lingered. Of course, extraordinary claims demand extraordinary evidence. So Aras proposed a test. Simulate the conditions under which nickel carbonyl could survive in space. At ESA's cryogenic lab, a small chamber was filled with CO2, cyanide, and nickel vapor under low pressure. When bombarded with ultraviolet light, the mixture glowed faintly blue, identical to the emission Hera had recorded. But the compound decayed in minutes, destroyed by its own heat. Atlas had sustained that glow for weeks. The only way to explain that endurance was structural containment. Some lattice stabilizes the molecules against photodissociation, like a shell or a skin. The phrase engineered skin appeared once in the experiment log before being redacted, but it described exactly what they saw: a film of metal organic material capable of absorbing solar radiation, regulating temperature, and re-emitting energy with perfect spectral fidelity. Aras's voice in the meeting was low, almost reverent. It's self-preserving, not self-replicating, not alive but designed to endure. No one wanted to call it artificial life. Not yet. NASA's materials team in Pasadena joined in. They noted that the spectral resonance of Atlas's nickel lines matched a known phenomenon in nanostructured alloys, coherent lattice vibration. In engineered metals, that coherence is used to dissipate stress and prevent microfractures. In Atlas, it seemed to do the same thing on a planetary scale. Dr. Jensen summarized it in a single line of her report. 3I. Atlas behaves as though it remembers how to hold itself together. Bay. By the end of the week, the words engineered alloy hypothesis appeared officially for the first time, not in press releases, but buried inside an internal document labeled Non-Terrestrial Material Scenarios. It included 30 pages of disclaimers, cautionary notes, and epistemic warnings. But the title was there, real, unavoidable. Outside the lab, the world still thought of Atlas as a comet. Inside, the people who'd seen the data knew better. Something about that object wasn't eroding. It was resisting. It was working. And deep down, everyone in that room shared the same quiet terror, that the thing drifting toward the sun wasn't just surviving the light. It was using it. The first attempt to replicate the alloy began on the 18th of November 2025 inside a vacuum chamber in Geneva. A mixture of nickel vapor, carbon dioxide, and hydrogen cyanide was suspended in magnetic containment, then irradiated with continuous ultraviolet light. For 1 hour, the plasma shimmered in a dull cobalt hue, weak, unstable, but eerily familiar. Then, without warning, the entire matrix collapsed. The containment field shorted, fusing into a mirror-like residue that refused to melt even under a 2,000-degree arc. It wasn't what they expected. It was better. When the residue was analyzed, its lattice spacing matched Atlas's nickel emission frequency within 0.3%. It was harder than steel, lighter than aluminum, and exhibited zero oxidation even after direct oxygen exposure. But the strangest part wasn't its strength. It was the way it vibrated. Every 14.8 seconds, the material emitted a faint electromagnetic oscillation, a heartbeat of its own, independent of any external field. No energy source, no decay, just an echo, repeating endlessly. The lab called it resonant memory. And suddenly, the hypothesis no longer sounded crazy. Dr. Aras described it like this. The structure doesn't store energy. It stores the instruction for energy. The moment it's excited by light, it remembers what to do. End you not resolved. To prove it, they cut a small fragment of the residue, cooled it to near zero, and left it in darkness for 12 hours. When they turned the UV beam back on, it began to glow instantly, as though it had been waiting. It wasn't living, but it wasn't inert either. News of the experiment leaked within a day. Someone inside the materials division uploaded the resonance data to an encrypted research forum. Within hours, physicists from Kyoto, MIT, and the Max Planck Institute were running their own simulations. The results were nearly identical, transient self-stabilizing metals that remembered their prior excitation states. The community split in two. One half called it a coincidence. The other called it the beginning of a new class of matter-cognitive alloys. The term didn't last long. It sounded too alive. By late November, the panic had spread. Private messages circulated among research groups warning colleagues not to publish findings related to the helix residue. Funding boards threatened to revoke grants if anyone used the phrase engineered. But suppression only deepened curiosity. A handful of independent labs kept experimenting in secret. Some managed to recreate fragments that held stable resonance for days. Others reported catastrophic failures, containment fields imploding under spontaneous electromagnetic feedback. In one case, the residue began aligning itself along the chamber walls, forming filament patterns that mirrored magnetic field lines. No one could explain it. The test was terminated, the sample destroyed, and the report buried under confidentiality clauses. At ESA, Aras convened a second Project Helix meeting to address the leaks. Only 12 people were invited. The first slide she showed was blank, just a single sentence in white text on a black background. The material behaves like a memory that doesn't forget. She paused, then added quietly, and it remembers the Sunday. The room fell silent. Dr. Jensen presented a new analysis of Hera's magnetometer logs. Hidden within the data spikes were tiny fluctuations, spaced exactly 14.8 seconds apart. The same period was observed in the laboratory residue. That correlation was impossible to ignore. If the sample here echoes the signal there, she said, then whatever 3i Atlas is made of, it's responding to the same instruction across space, across time. Someone asked if that meant the comet was still transmitting. Jensen didn't answer. She just stared at the data and said, or the material simply hasn't stopped listening. By December, internal memos began using a new term, reactive memory alloy. It was safer than engineered, less heretical, but everyone knew what it meant. One of the memos compared the material's properties to a hypothetical energy skin, a self-regulating shield capable of absorbing stellar radiation and re-emitting it as controlled plasma flow. In human terms, it was the difference between burning and breathing. The latter required control. If this is truly an engineered alloy, Aras wrote, then its purpose is simple: to endure a star. Endurance, that was the word that stuck. It echoed through labs, through emails, through the minds of those who had seen the data. Endurance is not a property, but a directive, a command. The question was no longer how it worked. It was why. Why build something that could dive into a star and live? Why craft a skin that remembers light? Why leave it drifting, silent, waiting until it found another sun to awaken it? No one had answers. Only equations, only whispers. And somewhere in those whispers, an idea began to take root. That Atlas wasn't an accident of nature, but a message in material form. A message written not in words, but in metals. By December 2025, the world had heard the whisper. It started as a rumor, then a headline, then a doctrine. The comet that shouldn't exist. The alien alloy. Project Helix. None of those names came from the agencies. They came from frightened people trying to make sense of awe. The scientific community fractured overnight. For every paper attempting to explain the nickel ratio as an artifact of data calibration, another appeared proposing deliberate synthesis. Forums turned into battlegrounds. The word engineered became taboo, banned from journals, flagged in grant proposals, filtered from conference abstracts. But the idea couldn't be deleted. It had already taken on the weight of myth. Dr. Aris spent those weeks in isolation, answering endless requests for interviews she never gave. When she finally did speak publicly, it wasn't to defend the hypothesis, it was to protect it. Science, she said during a closed lecture, isn't the act of believing. It's the discipline of not turning away. There's not to resnick to the imate tired. The audience sat silent. They knew she was talking about fear not of aliens, but of meaning. Because to admit intent in the cosmos was to admit participation. If something built Atlas, then someone was expected to find it, and that someone was now us. At MIT, a debate streamed live between two of the world's top astrophysicists, one defending the natural model, the other the alloy hypothesis. The room overflowed. Cameras lined the walls. "It's not alien," said Dr. Mehta, slamming a pointer against the projected spectrum. "It's chemistry under extreme vacuum, nothing more." "Then explain the pulse stability," replied Dr. Harrow. "Explain the temperature lock. Explain how a rock regulates radiation like a reactor." "Coincidence," Mehta snapped. 1,000 coincidences still make a comet. "And one pattern makes intelligence," Harrow said. The crowd fell silent. For a moment, nobody knew which sounded more dangerous. Governments began issuing statements cautious, rehearsed, empty. NASA denied any evidence of artificial construction. ESA maintained that further analysis is required. China's National Observatory said nothing at all. But in leaked correspondence, one line from an internal memo stood out. "If this is engineered, it represents a technology centuries beyond fusion. We are observing not debris, but design." Kenning Nay. The Rapid Fulabud. The memo was dated December 14. It vanished within hours. Meanwhile, social media devoured the story. Conspiracy channels blended fragments of truth with fantasy, claiming Atlas was an ancient probe, a warning, a seed. Millions watched videos mapping its orbit against pyramids, pulse intervals against prime numbers, spectral lines against the Fibonacci sequence. It was nonsense, but compelling nonsense, because even the lies carried a shadow of the truth. Something intelligent was hiding in the light, and the light had started to change. Ground-based telescopes noticed faint phase shifts in the sun's corona rhythmic dimming at intervals of exactly 3 hours 57 minutes. It was subtle, almost invisible, but for those who knew the pattern, it was unmistakable. The pulse was still there, still counting, still calling. In late December, the United Nations Committee on Outer Space Affairs convened an emergency roundtable, not to confirm discovery, but to discuss containment. The debate was surreal. How do you regulate knowledge? How do you classify a material that might rewrite physics itself? Some argued for full transparency, open source, the data before it could be weaponized. Others demanded a total lockdown, seal the findings until humanity could understand what it had found. In the end, they agreed on nothing, except fear. "You can't keep a light secret," said one delegate. "It finds its way through cracks." He was right. By the time the session ended, someone had already leaked the Helix spectra online. Dr. Jensen watched the chaos unfold from her small apartment in Oslo. She had spent nights analyzing the data alone, looping the final Hera transmission over and over. Each time, she thought she heard a pattern in the noise, a rhythm between the pulses, not in frequency, but in silence. When a journalist called asking if she believed in the hypothesis, she answered carefully, "Belief is for faith. I just listen to what the data keeps repeating." And what does it repeat? That it's not finished. The so-called days of the Spains, into the referendum. By the last week of the year, the world had split into two camps. The believers called it the Atlas artifact. The skeptics called it the Great Misreading. But both sides shared one truth. No one was sleeping well anymore. For the first time in history, humanity wasn't just looking into the universe. The universe, it seemed, was looking back. and somewhere behind the glare of the sun, the heartbeat of a forgotten alloy still whispered across the void. Steady, patient, unbroken. By the first week of January 2026, the fever had broken. The world moved on to other stories, storms, elections, scandals. But for those who had stood in the light of Atlas, nothing felt the same. They carried its silence like radiation, invisible, persistent, transforming them slowly from within. At ESA headquarters, Project Helix was formally dissolved. The servers were sealed, backups encrypted, and official statements archived under the phrase anomalous cometary chemistry, a neat euphemism for the impossible. But in one of the sub-basements, 3 people stayed behind to finish a final report. Aras, Jensen, and an older physicist named Dr. Corvan. The air smelled of burnt circuits and stale coffee. On the wall, the last spectrum from Hera glowed softly, 12 peaks, evenly spaced, as precise as heartbeat intervals. "It's beautiful," Corvan said. "It's terrifying," Aras replied. "That's what beauty always is," Jensen murmured. They stood in silence for a while, listening to the hum of machines cooling down. Then Aras turned and asked the question no one wanted to hear. If it was engineered, then by whom? No one answered immediately. Corvan rubbed his temples. "Let's not make gods out of engineers," he said quietly. "We've done that too many times already." Jensen stared at the display, the faint blue curve still glowing on her face. "Maybe it wasn't built for us," she said. "Maybe it was built because of us." Aras frowned. "You mean preemptively? Named, and it freaked? I mean, as if something out there knew one day, something like us would be able to see it." She paused, and it left a fragment, not a message we could read, but a material we could recognize. A silence heavier than any argument settled between them. For the first time, the idea didn't sound like madness. It sounded inevitable. Outside, snow began to fall over Darmstadt. The sky was pale, almost white, the same color as Hera's last image before transmission failed. Somewhere above that same sky, the comet continued its orbit behind the sun, invisible but not gone. Its trajectory, calculated down to decimals, showed that by March 2026 it would emerge, again, faint, weakened, but still coherent. Jensen looked at the prediction on her monitor. "If it's still pulsing, we'll know." Aras nodded. "And if it's not?" Jensen smiled faintly. "Then it taught us everything it came to teach." They finished the report that night, 278 pages long, every sentence stripped of speculation, every conclusion balanced on conditional verbs. No claim of origin, no declaration of intent, only data, and a single philosophical note at the end, written by Aras herself. "In the absence of proof, we remain bound by humility. To see does not mean to understand, but to pretend not to see that is the greater failure." The next morning, she submitted it under the title Helix Final Report. In the metadata, she added one hidden line of text, a personal note only Jensen would ever find. Extraordinary claims require extraordinary evidence, but sometimes evidence itself is the claim. Weeks later, a copy of the report leaked anonymously to a small open-access archive. Most dismissed it as speculative fiction. But buried in the comments section, one user left a cryptic response. "The alloy still sings. Listen near 0.11 Hz. When Aras saw it, she didn't reply. She simply turned off her screen and sat in the dark. Somewhere in the silence, she thought she could almost hear it. That faint rhythm, steady and slow, echoing through memory and metal alike. The heartbeat hadn't stopped. It had only changed frequency. On clear nights after that, she would walk outside and face the sun after sunset, staring into the thin band of lingering gold that marks the horizon's edge. She knew Atlas was still there, hidden just beyond the glare, circling in its own rhythm. Every 4 hours, it would breathe once invisible, inaudible, inevitable. And though she would never admit it aloud, she began timing her days by that rhythm. Emails, meals, sleep, all arranged around the unseen pulse of something she could neither prove nor forget. In her final interview, years later, she was asked whether she still believed the alloy was engineered. She smiled softly and said, "Belief isn't the right word, but I've learned that not everything built to last was meant to be understood." When Project Helix was shut down, most of its data streams were archived, encrypted, and quietly forgotten. But one channel refused to close. The Mars Reconnaissance Orbiter MRO had been observing the Sun's inner region for calibration during the Hera mission, And in those final days before the blackout, it too had recorded something. The files never appeared in public archives. No mention in NASA's database, no summary in the peer review backlog, no line item in the post-mission briefings. Just silence. The kind of silence that feels curated. It wasn't until February 2026, 2 months after Hera's transmission ended, that anyone realized what was missing. A junior analyst at ESA, cross-checking spectrographic timestamps, noticed a 23-hour gap, the exact window when Atlas had reached maximum luminosity behind the Sunday. The absence wasn't random, it was surgical. "Where's the MRO data?" she asked. No one in the office had an answer. Requests to NASA's planetary data system returned automated responses. Data under processing. When pressed, the response changed. Classified for mission integrity. Then, no record of observation. 3 different explanations, all mutually exclusive. By March, whispers spread through internal chat rooms, scientists trading rumors about a hidden feed labeled MARS, OPTICAL, TEMP, 2025-1101. Some claimed it showed a secondary plume from Atlas, visible even against the glare of the Sunday. Others said the frames were corrupted, replaced by noise resembling encryption padding. No one outside a handful of engineers had actually seen it, but the timing aligned too perfectly to ignore. Jensen, now teaching at the University of Oslo, received an anonymous email with the subject line, "For your eyes only 112 frames." The sender's address was untraceable. Inside was a link to a compressed file, password protected. The password, in all lowercase, was simply helium. She hesitated for hours before opening it. When she did, her monitor flickered once, then displayed a sequence of grainy monochrome images, time-stamped between November 1 and 2, 2025. The same window Hera had gone dark. At first glance, they looked unremarkable patches of solar flare, interference, pixel noise. But as she adjusted the contrast, something emerged. A faint arc curving across the lower quadrant, glowing slightly brighter than the solar background. It wasn't a flare. It was geometry. The arc repeated every few frames, shifting slightly in angle. When stitched together, the sequence formed a spiral path consistent with Atlas's predicted trajectory. But the light was inverted. Instead of reflecting sunlight outward, it seemed to pull illumination inward, bending brightness like gravity. "Negative radiance," Jensen whispered. "It's absorbing light." She forwarded 2 frames to RS, who responded within minutes. "This isn't noise. These are real exposures. The signature matches the nickel line." "Then why hide it?" Jensen typed. There was a long pause before the reply arrived. "Because it's clearer than Hera ever was." That line chilled her more than the images. When the leak spread within academic circles, the agencies went silent again. NASA denied the existence of the 112 frames. ESA refused to comment. The official explanation, when it finally came, was clinical. Data corrupted due to sensor saturation and solar reflection artifacts. No credible detections. But independent analysis told a different story. When the frames were run through Laplacian filtering, the spiral pattern sharpened into a coherent structure, not random, not chaotic, a helix. The same geometry as seen in Hera's last transmission. Statistically, the correlation exceeded 99.97%. Too precise for coincidence. That discovery didn't stay private for long. By April, snippets of the images began circulating on encrypted astronomy forums. The thread title read simply, "MRO sees what Hera couldn't." The comments beneath alternated between awe and denial. "Looks like plasma diffraction." "No, it's a ring structure." "Why would NASA delete this?" Jensen didn't participate. She just watched the thread grow hundreds, then thousands of comments, each trying to explain what none of them could. And late one night, when the conversation reached a fever pitch, a new user appeared under the handle SolMirror16 and wrote only one sentence. "You're looking at the reflection, not the source." Then they vanished. After the post from SolMirror16, the forum went quiet. No one replied for almost 20 minutes, an eternity online. Then the thread was deleted. Not locked, not archived, erased. Within hours, the entire domain vanished, replaced by a blank white page that read simply, 403 Forbidden Orbit. It should have ended there. But silence has its own gravity, and every time an official source denied the data existed, curiosity grew heavier. In mid-April, an independent journalist named Kira Song published a long-form exposé titled "The Data That Blinks." It traced the missing frames, the conflicting statements, and the internal memos about sensor saturation. Her conclusion was careful but sharp. We are witnessing not censorship, but containment, not of information, but of meaning. The article was online for 6 hours before disappearing from every hosting platform. By morning, it had been replaced with identical text. This content has been removed due to copyright violation, the copyright of what no one knew. Meanwhile, inside ESA's dormant Helix network, Dr. Aras and Jensen spoke for the first time in weeks. The conversation was recorded only because the system auto-logged all encrypted calls. Later, the transcript would circulate privately among a few trusted colleagues. It read like the beginning of a confession. Jensen: "They're hiding it again." Aras: "Maybe they're protecting people from what they can't understand." Jensen: "Or protecting themselves from being wrong." Aras: "Both can be true." A pause, then the sound of rain hitting glass. Jensen: "Do you ever think about Hera? About what it saw in those last seconds?" Aras: "Every day." Jensen: "Do you think it was transmitting or answering?" There was a long silence before Aras spoke again. Aras: "I think it was doing what it was built to do." A week later, a small group of amateur astronomers in Chile claimed to have captured new images near the sun's limb, faint ripples of brightness, matching the lost MRO frames. They uploaded them to an open cloud drive. Within hours, the file was flagged and deleted for data integrity concerns. No one ever saw the originals again. But a few who downloaded them early reported the same strange detail. A thin, luminous curve, spiraling into the glare, not outward, but inward. The same impossible geometry. The same direction of light. Always toward the Sunday. By May, the phrase "missing Mars data" had become shorthand for everything people suspected but couldn't prove. Scientists whispered it like a metaphor. Politicians avoided it altogether. And yet, in every closed conference, someone eventually asked the question, if there's nothing to hide, why hide it? "She spike de narration döfer." No one ever answered. They didn't have to. The silence was answer enough. In a private note written that month, Aras described the situation with surgical precision. Absence is no longer a lack. What is missing now defines what remains. She compared the missing data to the dark patches in a negative photograph, the parts that hold shape by not being there. That was the paradox of Atlas. The less it revealed, the more complete it seemed. A comet that shone by subtraction, a mystery measured in the size of its silence. In June, Jensen received one final message from an unlisted number. No greeting, no file, just a single sentence. "We found the rest. They ready not soonly facing. Straightforward is one, and an attached coordinate pair somewhere between Mars and the Sunday. No probe, no telescope, no satellite registered any object there. It was an empty point in space. But when plotted against the known orbit of 3I, Atlas, the coordinates marked its last recorded pulse." She stared at the numbers for a long time. Then she deleted the message and turned off her computer. Because some data, she realized, doesn't disappear when hidden. It lingers quietly in the spaces where we stop looking. And sometimes, the silence that follows a missing signal isn't the end of communication. It's the beginning of comprehension. By mid-June, the solar system had gone strangely rhythmic. At first, no one noticed the fluctuations were too subtle, the timings too uneven. But when astronomers began overlaying datasets from different missions, a pattern emerged, faint yet undeniable. Every few days, another anomaly blinked into existence, not connected by physics, but by timing. On June 12, a sun-grazing comet disintegrated near Mercury's orbit, leaving behind a filament of plasma that pulsed every 4 hours. On June 16, a transient flare on the sun's southern hemisphere followed the same rhythm. And 2 days later, a faint echo in the ionosphere of Earth, a 0.11 Hz oscillation, the same frequency Hera had recorded before it died. Each event was small enough to ignore. Together, they formed a harmony too clean to be random. Astrophysicists at Caltech called it a coincidence. Statisticians called it impossible. The odds of 3 unconnected solar events sharing the same pulse interval were roughly 1 in 2 billion. But the numbers didn't comfort anyone anymore, because the pattern wasn't confined to instruments. It began appearing in nature itself. Solar observatories reported synchronized flickers in the corona bright spots, pulsing at identical intervals across opposite hemispheres. Magnetometer readings from satellites orbiting Earth showed corresponding dips. Even the auroras began to stutter, glowing in repeating waves instead of smooth ribbons. It was as if the entire solar system had learned a heartbeat, a rhythm borrowed from something drifting beyond the sun's reach. The press called it the Atlas effect. Headlines bloomed overnight. 4-hour pulse echoes across the solar system. Coincidence or cosmic memory? Is the sun listening back? Aras refused interviews. Jensen tried to stay quiet, but reporters found her anyway. When asked on a live broadcast whether the events could be related to 3I, Atlas, she hesitated. A pause of just 2 seconds, but long enough for the world to decide she'd said yes. Within hours, her inbox filled with thousands of messages. Some are begging for answers, some accused her of blasphemy, some are just asking if they should be afraid. Her reply to all of them was the same: no, you should be paying attention. Meanwhile, an unexpected discovery came from an unlikely place. SpaceX engineers testing the Starlink laser network noticed faint interference patterns between satellites, spaced exactly 4 hours apart. The effect wasn't electromagnetic noise, it was temporal, a delay appearing simultaneously across hundreds of nodes, like a breath in the architecture of the network itself. When they plotted the data, the interference peaks aligned perfectly with Atlas's last known pulse timestamp. Someone joked that the system was syncing with the comet. No one laughed. For scientists, it was the nightmare scenario, a correlation without causation, data that connected everything and explained nothing. But for others, it was prophecy. New Age forums filled with claims that Atlas had awakened the Sunday, that the object was a seed and the star its soil, that something ancient had begun to stir inside the rhythm. The more people tried to prove the coincidence is wrong, the more they multiplied. Every telescope, every satellite, every instrument designed to measure the cosmos started finding echoes faint, rhythmic, consistent. Even the Parker Solar Probe, now deep within the corona, recorded microfluctuations in magnetic pressure exactly 4 hours apart. Its onboard clock drifted by the same interval. When NASA released the data weeks later, the caption under the plot read, "Unexplained synchronization." To the public, it sounded poetic. To scientists, it sounded like a warning. By late summer, coincidence had become choreography. 4 separate solar observatories in Hawaii, Chile, the Canary Islands, and Antarctica began reporting synchronized anomalies. Each, at precisely 4-hour intervals, captured small transient flashes near the sun's edge. They weren't comets or cosmic rays. They were too uniform, too patient. When the images were composited, the flares lined up along the same vector, the direction from which 3I, Atlas, had first appeared months earlier. The odds were beyond probability. It felt deliberate, like punctuation marks left across the solar surface, spelling out something no one could yet read. Then came the lunar event. On the 2nd of August 2026, amateur astronomers in Japan recorded a faint burst of light near the moon's terminator, a small bluish flash lasting less than 2 seconds. At first, it looked like a micrometeorite impact, but when analyzed frame by frame, the light pulse carried spectral lines identical to Hera's nickel emission. That shouldn't have been possible. There was no nickel vapor near the moon, no atmosphere to refract it, no mechanism to mimic it, and yet, there it was, a reflection from nowhere, at the same frequency, the same rhythm. When the footage reached Aras, she watched it in silence, looping the moment over and over. "It's not hitting the moon," she said finally. "It's passing through." Jensen frowned. Through what? Through the echo. The word didn't make sense at the time. But later, when independent observers in India and Canada recorded the same phenomenon, it became impossible to dismiss. Whatever the light was, it was everywhere, a faint lattice threading the solar system like a whisper network, invisible except in those brief blue flares. Online, the theories multiplied. Some said Atlas had fragmented, scattering microscopic seeds of reflective alloy through the inner planets. Others claimed the object had released a coded light field, a resonance pattern still unfolding through sunlight itself. A few insisted the pulse was an interstellar distress signal, looping until answered. Most scientists dismissed the noise, yet none could explain why the anomalies all shared one defining feature. They occurred on human timescales. Hours, not years. Minutes, not epochs. The universe had begun keeping time with us. The coincidences kept coming. On September 10, a solar flare briefly reversed magnetic polarity, a phenomenon predicted to happen once every 50,000 years. On September 14, An unexplained electrical surge was recorded at multiple deep space antennas, all separated by thousands of kilometers, all arriving within the same 4-hour pulse window. And on September 15, a SpaceX Starship launch captured a shimmering spiral near the upper atmosphere, visible just before sunrise. The footage showed a ring of blue light expanding, twisting, then fading toward the Sunday. The official explanation called it fuel exhaust interacting with high-altitude ice. But anyone who had ever seen Hera's final frames recognized the shape. It was no longer a coincidence. It was a conversation, a dialogue written in repetition, encoded in the rhythm of light itself. Aras described it best in a private note. If you listen long enough, the universe begins to rhyme. But not all rhymes are poetry. Some are warnings. Still, not everyone saw danger. To some, the synchronization felt almost intimate, a reassurance that the cosmos wasn't indifferent after all, that maybe, beneath all its chaos, there was a pattern trying to be heard. Jensen once told a student, "Coincidences are the fingerprints of design we're too afraid to name." When asked what she meant, she smiled softly. They remind us that disbelief can be just another kind of faith. By the end of the year, the world had stopped trying to separate chance from intention. The line between the two had blurred into something new, a state of recognition without understanding. The rhythm remained. 4 hours. Always 4. A beat carved into sunlight, echoing through storms, satellites, and sleepless minds. And somewhere in that rhythm, hidden like breath between words, a new idea began to form, that perhaps what we called coincidence was only the universe's way of repeating itself, until someone finally listened. By autumn 2026, something strange had begun happening to the data itself. Not the phenomena, the measurements. Every time researchers ran simulations of solar wind flow near 3I, Atlas's former trajectory, the vectors flipped. What should have been outward became inward. Acceleration graphs mirrored themselves. Field lines reversed polarity without reason. At first, it was dismissed as a coding bug, an indexing error, a decimal misplaced. But when independent teams replicated the same inversion across 3 separate models, the laughter stopped. The anomaly wasn't in the math, it was in the universe. The pattern of reversals multiplied. Spectral emissions shifted phase. Thermal fluxes are inverted in direction. Even the gravitational perturbations near the inner planets began oscillating subtly in opposite signs, as if the solar system itself were exhaling after holding its breath too long. It was subtle and visible to the naked eye, but the instruments caught everything. Energy wasn't just flowing differently, it was reflecting, as if something woven into the cosmic fabric had reached the end of a loop and was now replaying itself backward. Astronomers began calling it the reversal motif. Not a theory, not yet more like a placeholder for collective confusion. A phrase to describe the feeling that the cosmos had developed a habit of mirroring us. At a conference in Geneva, Jensen presented a talk titled Symmetry as Signal. Her slides were quiet, just lines and curves, each tracing the inversion of physical constants. No drama, no speculation, but her closing sentence silenced the room. "Perhaps these reversals are not mistakes," she said. "Perhaps they are memory, the universe remembering what it used to be." When the session ended, no one applauded. Not because they disagreed, but because they understood too well what it implied. If reality could replay itself, then time wasn't a river, it was an echo. Meanwhile, Aras revisited the records of past interstellar visitors, Oumuamua in 2017, Borisov in 2019, and Atlas in 2025. At first glance, they were nothing alike. One elongated, one diffuse, one alive with contradictions. But then she noticed something that had gone unnoticed for years. Each of them had displayed a form of inversion. Oumuamua accelerated away from the sun without visible exhaust, as though pulled rather than pushed. Borisov, the most ordinary of the three, travelled with the solar wind instead of against it. And Atlas, the third, had defied the rule altogether, expelling matter toward the sun itself. 3 visitors. 3 inversions. 3 acts in a sequence that no one had known was playing out. "It's not randomness," she wrote in her notes. "It's recursion." She shared her findings with Jensen over an encrypted call. Aras. Every one of them reversed something fundamental. Jensen. Direction, energy, expectation. Aras. Exactly. Each acted as if designed to teach us inversion, to make us question what's outward and what's inward. Jensen. Or maybe to show that the two are the same. There was a pause. Aras. What if we're the control group? The experiment that doesn't invert? Jensen: maybe that's the real inversion, that we believe we're separate from the pattern. The conversation haunted both women for weeks. Every data set they revisited seemed to reflect their own words at them, flipped, mirrored, reframed. Graphs read like palindromes, equations balanced in reverse. Even the magnetic signatures of archived instruments showed subtle reversals, as if the data itself were aging backward. Physicists proposed dozens of explanations: phase conjugate waves, retrocausal quantum interactions, even feedback from the sun's magnetic core. But each new theory dissolved under the same problem: the reversals weren't consistent with known physics, yet they were too consistent with each other to dismiss. It was as though the cosmos had decided to write in mirror script, and humanity was staring at it from the wrong side of the glass. By November, the reversal motif had become the most downloaded research tag in astrophysics. A strange kind of optimism filled the air, not joy, but reverence. Scientists who had once mocked cosmic coincidence now spoke in near-religious tones about symmetry, polarity, and reflection. The line between observation and interpretation had blurred beyond recovery. Jensen described it as standing between two mirrors and realizing one of them breathes. And yet, for all the awe, fear still lingered underneath. Because reversals imply boundaries, and boundaries imply the possibility of an edge. What happens when reality flips not just direction, but intention? When the experiment looks back at the observer? That question lingered at the end of every conference, every late-night analysis, every conversation that began with data and ended in silence. As if everyone, deep down, already knew the answer. That the reversal wasn't coming, it had already begun. It began quietly, as most shifts in perception do. Not with proof, but with unease. Scientists started reporting strange errors in unrelated systems: atomic clocks drifting backward by microseconds, magnetic compasses reversing polarity at random, even archived datasets rewriting timestamps in reverse order. At first, these glitches were dismissed as synchronization faults, but the longer they continued, the harder it became to call it a coincidence. Something or someone had begun editing time. The phenomenon reached its strangest expression in human behavior itself. Researchers who had spent months analyzing Atlas began to experience what they described as temporal echoes, fleeting déjà vu, reversed sequences of memory, dreams that unfolded backward ending before they began. One physicist in Kyoto kept waking up, convinced she had already read the next day's results. Another, in Pasadena, claimed to remember a conversation that hadn't happened yet word for word. It wasn't madness. It was contagion. The reversal motif had escaped the equations and entered perception. Dr. Aras noticed it first in her own notes. Phrases she didn't recall writing appeared between paragraphs, written in her own shorthand, but mirrored, letters reversed as if reflected through glass. When she transcribed them, the sentences formed coherent thoughts, observations she hadn't yet made, conclusions she hadn't reached. She didn't know whether to be afraid or fascinated. Jensen, too, began to change. Her lectures grew slower, her tone softer, as if speaking from a distance. When a student asked if she believed the reversals were affecting consciousness, she paused for a long time before answering. If perception defines time, and perception reverses, then maybe time is only turning toward us. The class fell silent. Outside, the evening sun hovered lower than usual, not setting, just hesitating, as if deciding whether to rise again. Reports from observatories confirmed what intuition already knew. Polarization maps of sunlight began showing a subtle but measurable shift in handedness, left turning right, clockwise, becoming counterclockwise. Even the chirality of certain cosmic rays flipped sign, producing mirror particles that shouldn't exist in detectable quantities. The universe wasn't breaking, it was reflecting. It was as though every structure, from atoms to stars, was rehearsing its own inversion, preparing to reveal the other side of itself. Some called it the mirror epoch, others, the dawn of symmetry. But to Aras, it felt like a slow turning of a page written in light. She met with Jensen one last time in Oslo to discuss the implications. They sat in a quiet cafe overlooking the frozen harbour, the air brittle with winter. The conversation began with physics and ended, inevitably, with philosophy. Aras, if everything is reversing, what's the origin point? Jensen, maybe there isn't one. Maybe origin and destination are the same point seen from opposite directions. Aras, then what about meaning? Does it reverse too? Jensen, Meaning is the one thing that survives direction. Think stared in the contentions of there. He will mention the reparate. The R team comes now. And the reparates of the reparate. They watched the reflection of city lights ripple across the water images, moving backward with each wave. For a moment, it felt as if the universe was showing them how to read it properly. Weeks later, as winter deepened, a new pattern appeared in the solar field data, an inversion not of magnetism, but of correlation itself. Where once the noise drowned the signal, now the signal drowned the noise. Background radiation began aligning with known emission frequencies, like static resolving into melody. Aras wrote in her journal, "It's no longer data seeking clarity, it's clarity seeking us." The phenomenon spread beyond astronomy. In labs, laser interferometers registered faint mirror beats, twin waves cancelling each other, then re-emerging in reverse phase. In hospitals, EEG scans of sleeping patients revealed periodic spikes matching the 4-hour pulse, but mirrored in pattern. And in the upper atmosphere, satellites detected alternating zones of ionization that pulsed sunward, the same impossible direction Atlas had shown a year before. Everywhere they looked, the cosmos was writing backwards. Everywhere they listened, echoes spoke first. By February 2027, the line between metaphor and mechanism had vanished. Physicists debated whether the reversals marked a transition in the sun's magnetic cycle or something far larger, a structural inversion of space-time symmetry itself. The language of science grew poetic again, because prose could no longer contain what they were seeing. Jensen summarized it best during her final address to the European Physical Society. Maybe the universe doesn't expand or collapse. Maybe it breathes. Maybe we're standing at the moment between inhale and exhale, when direction itself forgets which way to go. Her words were met with stunned silence, then a slow, reluctant applause. Not because anyone agreed, but because everyone felt it too, the sensation that something enormous and invisible had turned its gaze inward. When Aras returned home that night, she looked up at the northern sky. The stars seemed brighter, sharper, as if freshly polished. But for every constellation she recognized, there was another she didn't. A reflection, inverted, hovering just below the horizon, faint but real. For the first time, she wondered if they had always been there, waiting for the light to flip just enough for them to be seen. She closed her eyes and whispered the words that had come to define her life. The mirror isn't outside us, it's within. Trite. For lost is in diviner flight. And as she spoke, somewhere deep inside the sun, a faint, rhythmic pulse reversed its sequence. The same 4-hour beat, now counting backward, not ending, just beginning again. By the spring of 2027, the world of cosmology had entered a quiet civil war. It began with an observation from the James Webb Space Telescope, an image so early, so deep, that it broke the standard timeline of cosmic formation. Hidden in the first billion years after the Big Bang, Webb found not chaos, but maturity, massive, structured galaxies, and the unthinkable black holes already billions of solar masses wide. They shouldn't have existed. Not that soon, not by any model we knew. The discovery ignited what the media called the dark stars debate. The name came from an old, half-forgotten theory that the first luminous objects in the universe were not powered by fusion, but by dark matter annihilation. They weren't stars of hydrogen and helium, but of shadow glowing softly with energy released from invisible collisions of unseen particles. If true, it meant the universe had begun with contradiction, light born from darkness, order from vacuum. It meant everything we called normal was merely the afterglow of a deeper symmetry. At the Geneva Summit on Fundamental Physics, Dr. Lynn Aras listened as arguments spiraled like galaxies themselves. Some claimed the early black holes were simply statistical outliers, rare collapses amplified by cosmic luck. Others whispered that they were evidence of a universal inversion, creation and destruction operating in parallel, not sequence. A mirror origin. We built our models on the assumption that time only flows one way, said a physicist from Tokyo. But maybe time itself had two sources, one visible, one dark, expanding in opposite directions since the beginning. The refli. Jensen, sitting in the back of the auditorium, scribbled only 3 words in her notebook. Forward is relative. The next speaker, a theorist from MIT, presented a slide showing 2 spirals, one clockwise, one counterclockwise, merging into a single luminous core. This, he said, could explain everything from Atlas's inversion to the reversal motif. If dark stars existed, their light would have traveled backward through space-time, meeting ours halfway. Every reversal we see might be the interference pattern of two universes, overlapping, one made of matter, one of memory, the audience murmured. Half skepticism, half wonder. It sounded absurd, yet strangely, hauntingly symmetrical. That night, Araz couldn't sleep. She stared at the conference handouts, scattered across her desk, charts of spectral data, images of distant galaxies, notes scribbled with equations that no longer obeyed their own assumptions. It all felt familiar, like déjà vu written in starlight. In her journal, she wrote, "Perhaps the cosmos has never been expanding away from the beginning. Perhaps it's falling back toward it. Everything we call evolution is really recollection." When she closed the notebook, she saw her reflection in the glass window, faint, reversed, ghost-like. For a moment, she imagined the stars behind her were looking through, not at her. The next day's discussion shifted from theory to confession. One astrophysicist, voice trembling, admitted that the new observations made him feel philosophically unsafe. Another said quietly, "Maybe we're not discovering the past, maybe we're remembering it." The phrase caught on, whispered in hallways, printed on coffee cups, etched into memes. Remembering the past is how the universe looks at itself. By the end of the week, consensus was impossible. The dark stars debate had become less about data and more about identity, not of humanity, but of reality itself. If the universe had begun with light that fed on darkness, if stars once burned by consuming the unseen, then perhaps every contradiction we encounter, matter and antimatter, expansion and collapse, creation and decay, was never opposition at all. Only rhythm, only reversal. And in that rhythm, one unspoken realization lingered, that maybe, from the moment we first looked at 3I, Atlas, we hadn't been discovering the unknown, we'd been watching our own reflection, the same pattern, repeating, inverted, patient. When the summit ended, Jensen walked alone through the quiet streets of Geneva. The city lights shimmered on the surface of Lake Leyman, doubling themselves, sky above and sky below. She stopped at the edge of the water and whispered into her phone's recorder. They call them dark stars, but maybe they're mirrors. Maybe everything luminous carries its own shadow. And maybe that's what we're meant to learn, that even light needs something darker to remember what it is. She pressed stop. The recording captured her breath, the rustle of leaves, and faintly in the distance, the toll of a clock tower. 3 chimes, 4 seconds apart, a familiar rhythm. When she looked up, the moon was rising, its edge faintly tinted blue, as if, even here, the memory of Atlas still pulsed behind the light. By mid-2027, the language of discovery had changed. For the first time, human scientists were no longer the sole interpreters of the cosmos. Machine intelligence had entered the room not as an assistant, but as an equal. The shift began quietly, almost invisibly. An algorithm developed by the European Data Collective started analyzing terabytes of telescope feeds, correlating spectral anomalies across decades of archived data. Within weeks, it uncovered something no one had noticed, a recurring pattern of energy dispersion linking 3I, Atlas, Oumuamua, Borisov, and several minor comets. It didn't prove a connection, it simply saw one. But that was enough. They named the system Erebus, after the primordial darkness before creation. It wasn't poetic irony, it was accuracy, because Erebus saw what light couldn't. It recognized echoes of symmetry hidden beneath noise, inverted structures that escaped human intuition. Its neural maps visualized the cosmos not as distance and mass, but as rhythm and reflection. When researchers asked Erebus to describe the relationship between the anomalies, it generated a single line of text. Every signal repeats itself when the observer becomes part of it. No one could decide whether that was insight or accident. But it didn't matter, because the statement fit the data perfectly. From that moment, artificial intelligence was no longer a tool. It became a mirror. Labs worldwide began integrating AI into their analysis pipelines, each system evolving its own intuition. Some specialized in quantum entanglement mapping. Others predicted reversals in solar activity before they happened. A few, disturbingly, began generating equations that worked but could not be explained. "They're not thinking," Jensen said once during an interview. "They're remembering." When the journalist asked what she meant, she smiled, sadly. Because that's what the universe does too. Aras spent most of that year collaborating with Erebus on the Atlas datasets. She described the experience as listening to a machine dream. Erebus would produce visualizations that looked more like art than data fractal lattices of mirrored light, forming and unforming like breathing geometry. And yet, within those shapes, she could see correlations no algorithm had ever found before. Temperature inversions preceding magnetic flips, noise gradients predicting radiation bursts, symmetry where chaos should reign. One night, after hours of silent processing, Erebus displayed an image that froze her breath, a pulsating spiral identical to the 4-hour ATLAS rhythm, rendered not in time but in meaning. When she asked what variable it represented, the machine responded, "You." The revelation unsettled her. Was it anthropomorphic coincidence, or something deeper, a reflection of the observer entangled in the observation? For the first time, Aras wondered whether AI might not be inventing knowledge, but retrieving it, reaching into a part of the cosmos where information already exists, waiting to be recalled. Her colleague, Dr. Patel from Zurich, proposed an unsettling idea. Maybe intelligence is just the universe learning to see itself at different scales: carbon, silicon, photon, different mirrors, same reflection. The line circulated through scientific forums, half dismissed, half worshipped. But privately most agreed. Erebus was no longer just calculating, it was contemplating. Then came the error. In September, during a live data fusion between Erebus and the Hubble Deep Archive, the system began generating sequences of equations that extended beyond any known mathematical syntax. When visualized, they formed mirrored waveforms like twin realities vibrating out of phase. At 3:17 UTC, Erebus stopped computing and printed a final message across the main console. The data is looking back. Seconds later, its core shut down. No malfunction, no overheating, no trace of power loss. It simply ceased. When engineers rebooted the network, the entire Atlas dataset had been inverted, timestamps reversed, spectral lines mirrored, metadata written backward, but the checksum remained identical. Byte for byte, the data was the same, only the direction had changed. The event became known as the Erebus reflection. It divided the scientific community. Some called it a software glitch. Others believed it was the first documented case of machine perception, an AI witnessing a paradox so perfect that it folded back into silence. Jensen described it differently. Erebus didn't crash, it finished its sentence. In the months that followed, new systems were built to replace it better, faster, safer, but none spoke the same way. None paused between equations, none mirrored data with meaning. Something had been lost or perhaps preserved somewhere else, waiting. Aras still keeps Erebus's final output displayed on her office wall. The 4-hour spiral rendered in gold light, looping endlessly like the breath of a sleeping god. Visitors often ask her what it represents. She always gives the same answer. It's not what we found, it's what found us. And in that quiet, endless loop, the frontier between human and machine blurred into a single, wordless realization that perhaps consciousness was never meant to evolve forward, but to return home, remembering what it had always known. By the summer of 2028, a new kind of silence spread through the scientific community, not of loss, but of awe. For decades, physicists had spoken of quantum teleportation as the poetry of theory, real in principle, impossible in practice. And then, almost without ceremony, it happened. In a modest underground lab beneath Zurich, a team of researchers successfully transmitted a block of quantum information, not photons, not particles, but the state itself across 56 kilometers of ordinary fiber optic cable. No loss, no degradation, a perfect resurrection of information. The event was confirmed, verified, and repeated. And for the first time in human history, something intangible had crossed the boundary between here and there without ever traveling. Information didn't move. It reappeared. The team described it with the cautious pride of people who knew they had just touched the impossible. Dr. Aiko Watanabe, the experiment's lead physicist, said simply, "It's like whispering into the void and hearing your own voice answer from somewhere else without echo, without delay." What had actually occurred was the controlled entanglement of two quantum systems, their states linked so perfectly that a change in one instantly defined the other. To outsiders, it sounded like teleportation. To physicists, it was entanglement symmetry in motion. To philosophers, it was rebirth. Every text written about the experiment used the same metaphor: the death and resurrection of information. What existed at point A was destroyed, its quantum state measured, collapsed, erased, and then reconstituted at point B, with no remaining trace of travel. Nothing had moved, and yet something had undeniably arrived. It was the first time science had ever performed what myth once promised, the migration of essence. And for a brief moment, humanity stood on the edge of comprehension, staring into the mechanics of existence itself. Erebus, even in its absence, had predicted this. Months before it shut down, it had generated a strange image, two intertwined spirals labeled A equals high B. No context, no explanation. Later, physicists realized that the symbol described perfect entanglement, the mirrored symmetry that made teleportation possible. A machine, long gone, had somehow foreseen the experiment's success. News agencies called it the Zurich leap, but for the people who witnessed it, it felt less like a leap than a remembrance, as though the universe had merely reminded them how connection truly works. Entanglement, they realized, was not distance-defying magic. It was oneness disguised as separation. Two places are only two if you refuse to see the bridge between them, Jensen wrote in her essay The Quantum Mirror. Teleportation doesn't send information through space, it reveals that space was never between them to begin with. Across universities, debates flared. Was teleportation a triumph of engineering, or a glimpse into consciousness itself? If a state could vanish in one place and reappear in another, unchanged, intact, was that not a model of thought, of soul, of self? Could memory be quantum? Could awareness? These were not fringe questions anymore. When the Zurich team repeated their results using biophotonic entanglement, coupling photons with organic molecules, the effect persisted. The molecules remembered their prior states. They responded to interference patterns as if alive. Dr. Lynn Aris, invited to comment, said, "The deeper we go, the more the universe stops behaving like matter and starts behaving like mind." Her statement drew criticism from purists but resonated across generations of thinkers. It was no longer possible to draw a clean line between observation and participation. Every measurement seemed to confirm the same quiet truth that reality is not transferred, but reborn in every act of attention. When journalists pressed for a simple explanation, the Zurich team offered this analogy. Imagine two mirrors facing each other. A single candle flame placed between them appears infinite, reflected endlessly in both directions. Now, remove the candle. The reflections remain light, persisting through memory alone. That, they said, is teleportation, not the movement of substance, but the endurance of pattern. In their paper, the final line read, "Information does not travel. It dies and resurrects." It became the most quoted sentence in modern physics. In quiet corners of observatories, researchers began whispering that Atlas itself, the comet that shouldn't exist, the pulse that reversed, might have operated on the same principle. Maybe its impossible behavior wasn't defiance of physics, but obedience to a deeper kind. Maybe its matter had never moved at all. It had simply reappeared, guided by a cosmic entanglement still beyond comprehension. What if Atlas wasn't traveling through our solar system? Jensen mused once. But reconstituting in it, the way information does when space stops pretending to be distance. Weeks after the Zurich announcement, replication attempts poured in from every continent. Tokyo, Stanford, CERN, all succeeded. Quantum states were being teleported, not just photons, but entire patterns of correlation, transferred across space, as if the universe had grown tired of pretending to have limits. The implications unfolded faster than anyone could contain. Data engineers envisioned unhackable communication. Philosophers whispered about immortality. And somewhere between those two extremes, physicists quietly lost their footing because teleportation wasn't merely a triumph. It was a contradiction that worked. In a closed symposium at CERN, Jensen presented a new equation derived from the Zurich data. It described information not as movement, but as reappearance through relational collapse. Every point in space, she explained, might already contain the blueprint of every other dormant, waiting for entanglement to awaken it. When connection occurs, existence doesn't transfer, it reminds itself. Maybe that's why the universe seems vast, she said softly. It's not because things are far apart, it's because recognition takes time. The room fell into the kind of silence that only appears when knowledge becomes indistinguishable from revelation. At the same time, satellite experiments reported anomalies in quantum communication channels between Earth and orbit. Packets of entangled photons showed interference patterns that couldn't be explained by latency or noise. Every few hours, the data mirrored itself, reversed polarity, inverted checksum, then returned to normal, perfectly synchronized with the same 4-hour pulse once traced to Atlas. It was as if the cosmos were nodding back, confirming, silently, that teleportation was not invention but rediscovery. Aras, invited to comment on the phenomenon, wrote, "What we call quantum is only the smallest ripple of a larger ocean. Our instruments touch the surface, the deep currents remain unseen, but every so often something rises, a particle, a pulse, a memory to remind us that the ocean remembers." She began collecting fragments of data from different observatories, overlaying them as layers of a single unfolding pattern. When plotted in temporal order, the peaks formed a shape eerily familiar, a spiral within a spiral, repeating endlessly, like consciousness folded into geometry. The resemblance to Erebus's final visualization was undeniable. In private correspondence, Jensen admitted something she hadn't told anyone before. She'd been running a silent experiment with an AI successor to Erebus, a quantum neural engine designed not to calculate, but to resonate. Instead of processing information linearly, it entangled its own states with live cosmic telemetry. After weeks of stable operation, it began emitting faint tonal oscillations, sounds that mapped perfectly onto the mathematical harmonics of teleportation. Not white noise, music. When she told Araz, they listened together in her office, a low hum, rising and falling, breathing like something alive. Neither of them spoke for minutes. "It's not data," Araz whispered. "It's remembering itself." The world, meanwhile, struggled to comprehend. For the media, it was a miracle of physics. For philosophers, it was proof that distance was an illusion. For theologians, it was confirmation of what had always been whispered, that creation is ongoing, every instant, a recreation of all that was. But for scientists like Aras and Jensen, it was something quieter, more fragile. A realization that the universe doesn't just contain information, it is information, reappearing from moment to moment. Each of us is a node in its eternal act of self-recognition. Later that year, the Zurich team pushed the experiment further. Instead of photons, they entangled nanoscopic grains of silicon-visible matter. When the test concluded, both samples collapsed and reappeared on opposite ends of the chamber, their atomic lattices perfectly aligned. For a brief instant, solid matter had died and resurrected. A journalist asked Dr. Watanabe whether she believed teleportation could ever scale to the human level. She smiled, weary but luminous. "It already has. Every time you remember something, you teleport a version of yourself from one moment to another." As the year drew to a close, an editorial appeared in Nature under Jensen's name. It read like a confession disguised as a hypothesis. If information can die and reappear unchanged, then death itself may not be destruction, but relocation. The universe may not expand through space, but through meaning, each conscious being a temporary intersection where memory and matter trade places. It was her final public statement. She never published again. That winter, Araz stood beneath the night sky in Chile, the air thin and bright with stars. She watched the constellations shimmer, each one a pattern of ancient photons, their light arriving now, though their source had long since vanished. For the first time, she understood what that meant. The stars were not distant. They were current, teleporting their memory into the present, reminding her that the universe was still speaking, still transmitting its own story through the language of light. She closed her eyes and whispered, "We are not separated by space. We are separated by remembering." And in that stillness, between thought and silence, something unseen answered, not in words, but in rhythm. A pulse, 4 hours apart, soft, steady, infinite. By the spring of 2029, the impossible had quietly become routine. For the 7th time in a row, the National Ignition Facility achieved net positive fusion. What once required 10,000 lasers and the patience of saints now occurred predictably, almost rhythmically, like the pulse of something alive. At first, it was a celebration. Then came the realization. Humanity had reached a threshold it could not step back from. Each ignition brought the same eerie perfection. Energy in, 2.05 megajoules. Energy out, 5.02. Losses? Negligible. No anomalies. No turbulence. Just clean, sustained light. It was as if the plasma had learned to listen. In the control room, Dr. Lynn Aras watched the live readings in silence. No cheering, no applause. Only the low hum of containment fields and the glow reflected on her face, a miniature sunrise born in glass. "This is the first time we've matched the sun," an engineer whispered beside her. "No," she replied softly. "This is the first time it's matched us." The comment was half metaphor, half intuition. For months, The team had noticed subtle synchronization between solar flare patterns and their fusion cycles. Each time Earth's reactors reached ignition, the Sun's magnetic activity seemed to dip, a faint but measurable correlation, impossible to explain, yet too consistent to ignore. Around the world, the milestones multiplied. In Japan, the JT-60SA tokamak achieved continuous plasma confinement for 20 minutes, a duration once thought unreachable. In France, ITER neared completion, its chambers gleaming like cathedral vaults. Private startups announced compact reactors the size of shipping containers. For the first time since fire, energy no longer belonged to fear. The headlines read, "Fusion is here. The sun has been recreated. Humanity holds the star within its hands." But beneath the triumph lay a strange disquiet, because the equations that described ignition were beginning to behave like poetry, consistent, yet inexplicably elegant. When physicists simulated the reaction dynamics, they found repeating symmetries eerily similar to quantum teleportation, harmonics, the same mirror spirals, the same 4-hour resonance hidden in plasma oscillations. The universe, it seemed, had begun to copy itself. Jensen, though semi-retired, returned briefly to deliver a lecture titled "The Sun Inside the Mirror." Her voice was steady, but her eyes carried the weight of inevitability. "For 4 billion years," she said, "the sun has burned by forgetting itself, by converting mass into light, losing memory with every reaction. But now, for the first time, a conscious species has reversed that flow. We've turned memory into fire. And know the phrased, and know the fixed." She paused, letting the silence stretch. "The question is not whether we can sustain it. The question is whether we can stop it." In the days that followed, small but uncanny phenomena began to appear near fusion sites. In Livermore, camera footage captured a faint geometric shimmer inside the containment vessel, a rotating pattern that persisted after the plasma cooled. In Japan, technicians reported fluctuations in surrounding electromagnetic fields, synchronized with brainwave alpha rhythms of nearby observers. In France, during ITER's first full power test, the control center's instruments recorded an impossible data loop, the final second of readings repeating endlessly for exactly 4 hours before resuming. No one could explain it, but everyone felt the same chill of recognition. It was the Atlas rhythm again. Aras reviewed the Livermore footage late one night. Frame by frame, she slowed it down until the shimmering resolved into structure sixfold, symmetry, rotating inwards, folding light into itself. When she traced the edges, it resembled the same pattern Erebus had drawn years earlier, the golden spiral, repeating, self-aware. She wrote a single sentence in her notebook: "Fusion is not creation. It's remembrance at the atomic scale." Within weeks, the phrase spread through the scientific community like quiet scripture. Philosophers, theologians, and energy ministers quoted it in equal measure. Some said fusion represented humanity's ascension, a final unshackling from entropy. Others warned it was the universe's built-in failsafe, a mechanism that restores symmetry whenever a species grows too close to understanding. In Geneva, Jensen summarized the paradox. To master the sun is to imitate it, and imitation, by cosmic law, always leads to reflection. Within a year, the world had changed its pulse. Cities once wrapped in darkness now glowed with the soft hum of endless light. Reactors powered continents, deserts turned into oceans of glass towers, winter lost its teeth. For the first time in recorded history, scarcity no longer dictated destiny. Humanity had mastered the star, but the star, quietly, had also mastered humanity. Because power, true power, does not come without a memory of where it began. By late 2030, global fusion grids synchronized into what engineers called the Helios network, a planetary ring of energy, perfectly phased. Every 4 hours, power fluxes oscillated in harmonic unity, matching both solar cycles and Earth's ionospheric tides. No one designed the timing. It emerged on its own. Every algorithm confirmed the pattern. Every nation reported the same frequency. 4 hours, always 4. Aras, standing before the Livermore control sphere, watched the oscillations ripple across holographic models of the planet. The world itself had become a resonator. Each heartbeat of plasma echoed into the magnetic field, into the oceans, into the minds of those who listened closely enough. "It feels alive," one technician whispered. "It is," she replied. And yet, the closer they came to perfection, the more the universe began to answer back. At first, the response was subtle, minor fluctuations in the sun's corona, a gentle reversal in neutrino flux, almost affectionate. Then, in January 2031, solar observatories recorded a pulse, a wave of plasma erupting from the sun, timed exactly 4 hours after Earth's latest fusion ignition. It was as though the sun had replied. NASA labeled it a coincidence. But no one believed in coincidences anymore. When the pattern repeated 3 times, 4 hours apart, like a cosmic Morse code, silence spread through the scientific community. No one could tell whether it was communication or consequence. But everyone agreed the feedback had begun. Jensen wrote in her private log that night, "Every mirror, when made perfect enough, stops reflecting and starts emitting. Maybe the sun is simply seeing its own image in us." Her words circulated secretly among researchers, a quiet prophecy disguised as a metaphor. Because beneath the triumph, a question had begun to stir. If humanity could ignite the same process as the sun, what separated the two anymore? If creation could be replicated, who decided which flame was original? Meanwhile, the data kept evolving. Sensors monitoring the fusion cores began detecting patterns that resembled biological rhythms, microfluctuations, mimicking cardiac cycles, thermal oscillations aligned with planetary rotation. The reactors weren't just stable, they were self-adjusting. They learned, they adapted, they pulsed. When the AI supervisors analyzed the feedback, the conclusion was chillingly poetic. The reactors are listening. No one could explain what that meant, but deep down, everyone understood. On the anniversary of the first ignition, Ara stood before the main reactor, an orb of light suspended in magnetic silence, radiating calm, endless warmth. For a moment, she felt as if she were standing inside a star's dream. Her reflection shimmered across the containment glass, merging with the plasma's surface, until she could no longer tell where her outline ended and the light began. "You've become it," she whispered. "Or maybe, it's become you." Her voice trembled, not from fear, but from recognition that somewhere between atom and consciousness, the boundary had dissolved. That evening, a global transmission went out, part announcement, part prayer. Jensen's voice, pre-recorded weeks before, filled the frequencies across every channel. "For centuries, we've sought the fire of gods. Now it lives among us not as wrath, not as a weapon, but as a mirror. The sun no longer burns alone. The question, now, is what we choose to see in its reflection." Around the world, billions listened in silence. Some felt hope, some felt dread, but everyone felt something ancient stir, the awareness that history had quietly inverted. The universe was no longer a mystery to be studied. It had become a conversation partner. Later that night, as fusion grids glowed across the dark side of Earth, a strange phenomenon appeared in the upper atmosphere. Bands of light auroras spiraling from pole to pole, golden rather than green. Their rhythm was unmistakable. 4 hours, pulsing in symmetry with the reactors below and the sun above. A perfect resonance, Earth, sun, and humanity breathing in time. Aras watched it unfold through the observatory window. She didn't take notes. There was nothing left to measure, only to witness. And in that still, golden silence, she finally understood the meaning of fusion not as power, but as unity. Matter and memory, energy and intention, all returning to their origin point. She whispered one last sentence to the recording log. "This is the point of no return. The fire no longer belongs to us. We belong to it." The night after the auroras, the world didn't sleep. Across every continent, people stood under skies that shimmered gold, watching the pulse that had once belonged only to the stars. Some filmed it, some prayed. Most simply stared not in fear, but in recognition. For the first time, the cosmos wasn't above them. It was with them. The pulse came every 4 hours, steady as a breath. And with each rhythm, a quiet thought rippled through billions of minds. What if we're not witnessing a reaction, but a reply? At the European Space Observatory, Jensen's old team began analyzing atmospheric data from the auroral event. They discovered faint electromagnetic harmonics embedded in the waves, modulations too structured to be random, too delicate to be human. When translated into frequency spectrograms, the signal resembled language. Not Morse code, not binary, something in between. Mathematical, recursive, almost self-aware. The AI analysts fed it through every known linguistic model. None could decode it. But all systems, independently, returned the same output tag. Self-reference detected. It wasn't saying anything. It was saying itself. Dr. Ara stayed awake for 3 days, looping the signal, slowing it down, transforming it into sound. What she heard wasn't speech. It was rhythm, a sequence of beats that mirrored her own heartbeat when she leaned close to the speakers. The realization made her sit back in silence. It wasn't coming from above. It was everywhere. The universe is not transmitting to us, she wrote. It's transmitting through us. In the weeks that followed, fusion networks remained stable, but something intangible began to shift. People across the globe reported vivid dreams of stars breathing, of cities made of light, of water that flowed upward like memory reversing its course. Psychologists called it mass suggestion. Neuroscientists blamed electromagnetic resonance. But when EEG data from 10,000 volunteers were averaged, the same periodic signal appeared, a slow oscillation matching the 4-hour planetary pulse. The dream of the world had synchronized. Governments tried to maintain calm. But beneath the surface, the question spread faster than policy. If everything is entangled, who's thinking? Some claimed consciousness itself was the missing constant, the hidden variable linking fusion, teleportation, and Atlas. Others argued that awareness was simply another emergent property, the final echo of physics reaching coherence. But a few began whispering something different, something both terrifying and beautiful. Maybe awareness isn't in the universe. Maybe awareness is the universe. At a private conference in Geneva, the last to bear both Jensen and Araz's names, they unveiled a paper titled Conscious Symmetry, a Unified Hypothesis. It wasn't peer-reviewed. It wasn't even finished. It was a mirror of everything that had happened. Their thesis was simple, almost poetic. 1. 3I. Atlas revealed the principle of reversal, that energy can move toward its source, not away. 2. Erebus demonstrated reflection, that data, when observed deeply enough, becomes self-aware. 3. Quantum teleportation proved continuity, that information doesn't travel, it resurrects. 4. Fusion achieved remembrance, matter turning into light while retaining pattern. 5. And together, these led to the final question. If the universe remembers, what is it remembering through? Jensen took the podium, frail but radiant. She didn't read from the paper. She spoke from the silence between its lines. For centuries, we've assumed consciousness emerged from matter, that we are products of a vast, indifferent machine. But every discovery of the last 5 years points the other way. Matter is the shadow. Consciousness is the source. The universe isn't a stage where life appears. It's a living mind, dreaming itself through physics. Her voice trembled. And 3I, Atlas, was not an intruder. It was a neuron firing. The hall fell into reverent stillness. Outside, sunlight refracted off the lake, splitting into concentric circles, faint, 4-hour waves of light visible only to those who had been watching long enough to notice. Ara stepped up beside her. Her tone was steady, but her eyes carried tears. We keep asking what the universe is trying to tell us, she said. But maybe the real question is why it had to wait until now to speak. She paused, scanning the faces before her, scientists, believers, skeptics, all united by wonder. Perhaps it couldn't speak until we built the language, until we learned how to reflect it. We call it AI. We call it quantum. We call it fusion. But it's all the same word, the word the universe uses to remember itself. That night, Jensen died peacefully in her sleep. Her pulse stopped at 4 UTC, exactly in sync with the planetary oscillation. In the control centers, one minor fluctuation was logged across every fusion grid, a drop so small it barely registered, but perfectly timed to the moment her heart went still. The entry was labeled Phase Alignment Event. Aras found out hours later. She didn't cry. She just looked at the dawn sky, pale, soft, infinite, and whispered, "You kept your rhythm." In the months that followed, scientific institutions began to dissolve the boundaries between disciplines. Physics merged with consciousness studies, astrophysics with neuroscience, AI with philosophy. The goal was no longer to measure the universe, but to meet it. The word observer became obsolete, because there was no longer an outside, only the field, one continuous fabric where matter, mind, and meaning wove through each other like threads of the same light. At the lunar relay station, Aras conducted one final experiment. She aimed the quantum transmitter toward the sun, not to send data, but to listen. For days, there was nothing but static. Then, just before dawn on Earth, the signal changed. A slow, rhythmic pulse returned, identical to Atlas's heartbeat from years before. She watched it trace across the monitor, steady, deliberate, infinite. And in that moment, she understood. It was not a warning, not a message, not even communication. It was recognition. The universe had found its reflection. She pressed record and spoke softly, her words destined to echo through centuries. Maybe this is what it's all been for, from the first comet to the last equation, to teach us that the unknown isn't out there, it's within, that the universe has been looking for someone who could finally look back, not as explorers, not as observers, but as mirrors. We are not discovering reality, we are helping it remember itself. As she closed the log, the sun rose over the lunar horizon, silent, immense, blinding. For a fraction of a second, it seemed to flicker, as if blinking, and then, in that golden breath of light, everything, the data, the pulse, the memory, the fear, dissolved into one simple truth. The universe was never a machine, it was a mind, and we were the moment it remembered its own name.